gave this concept because no one was accepting. It was the first time accepted by Einstein in 1905 because Einstein gave his photoelectric effect. You remember? Photoelectric effect. Let me just talk about it from the top. What is photoelectric effect? It is when a light of a certain radiation falls on the metal surface, electrons are ejected from the metallic surface. Now this concept was already noticed before, but the observations could not be explained unless and until one takes care of the Planck's hypothesis. You getting the point? Planck gave his concept of quantization, but it was a sudden jump from macro to the microscopic world. That was not accepted. So till in 1905, Einstein explained the photoelectric effect using the Planck's hypothesis. You understand the historical developments? And then what happened in 1907, because the atomic model was also developing simultaneously. Dalton gave his model which failed at various steps. We'll look into the failures and the advantages. But then in 1907, Thompson gave his plum pudding model. So that was like a model which had no base at all. So that is why it was like rejected and not had many drawbacks. Then in 1911, Rutherford did his famous experiment with the alpha particles. And he gave the first nuclear model of the atom. He gave the first nuclear model. Why? Because his model had a nucleus in between and then it had the electrons revolving around it. Okay, so Rutherford actually stated that you have a nucleus which has the electrons revolving in specific orbits around. And then in 1913, Bohr actually refined the model and he gave the first quantum model. Quantum model of, because he talked about the theory of quantization in the atomic structure. And then things went on to develop. The dual nature was also given finally a call by de Broglie. De Broglie actually talked about the dual nature of light also, and de Broglie's principle was given in somewhere around 1923. Then in 1926, Schrödinger 25 or 26, Schrödinger gave his quantum model of the atom, and that was like very widely accepted. Schrödinger gave his equation, that was the Schrödinger wave equation. We will talk about it. This equation will help you solve the structure of the say the atomic model that was in particular solved only for the hydrogen atom. And thereafter things were like eased out a bit because you got a perfect quantum model. And let me tell you, the Schrödinger wave equation that he gave, was also a postulate. This equation has no derivation, but it's a postulate. Again, what is a postulate? That from my logical deductions I am making that this is a postulate. Now we can prove that this postulate turns out to be correct. If it turns out to be correct, it will be widely accepted. Got it? So that is how. So what you are going to do in this topic is not child's play. It was like done over years and years that you will just be doing in about a class or two. Now here I repeat, right from 200 and 300 BC, scientists were always interested. So what they did, they used to grind the elements in mortar and pestle, and the smallest, tiniest particle that they got, from that they concluded that there exists a small entity which cannot be divided further. This was the concept that was given initially. Then Dalton gave his atomic theory where he stated that your atoms are indivisible. He talked about a concept of atoms which are indivisible. And then thereafter there were developments like Newton gave his corpuscular theory of light. In 1870 Maxwell talked about the wave nature. Electromagnetic radiations were talked about at that point in time. And all this was related to your classical mechanics. And what is your classical mechanics? It is the science dealing with macroscopic objects. Okay. And then thereafter in 1900s, suddenly a concept came, that was the concept of quantization. That is why Max Planck is also sometimes called the father of quantum mechanics. Why? Because all this that is based on quantum mechanics, you have classical on one side, and quantum mechanics is the study that deals with microscopic particles. So quantum mechanics is the study that deals with microscopic particles. So here then came the concept of quantization by Planck, which was again not accepted till 1905. Einstein explained the photoelectric effect. And what is the photoelectric effect? It is the ejection of electrons when a light of certain radiation, certain frequency falls on the metallic surface. This is like the explanation of photoelectric effect. Then in 1907, Thompson gave his plum pudding model, which was again not a successful model. In 1911, Rutherford talked about the nuclear model, wherein he performed his alpha ray scattering experiments that we will talk about. So in that he talked about a nuclear model. Now why a nuclear model? Because he talked of a separate subatomic particle which was a nucleus, and it had the electrons revolving around it. You had the nucleus in the middle and the electrons are revolving around it. So then Rutherford also could not explain certain things like the stability of atom, etc. In 1913, Bohr gave the first quantum model. Why? Because his studies were based on, it was like a combination of classical and the previous studies along with the touch of quantization. And finally in 1926, Schrödinger gave his Schrödinger wave equation. We'll just look into it from the top. And remember that there is no derivation of the Schrödinger wave equation, it is a postulate. Okay, and then thereafter, then there were like modification of just this equation to solve your systems further. Like for example, initially the interest was only in the most basic atom which is available, which is hydrogen atom. So now let's do it in detail. Just remember that this is how atomic structure developed, and now you have a knowledge of this branch which deals with macroscopic objects, that is called classical mechanics. It is basically based on the Newton's laws of motions. Okay, and then there is the quantum mechanics, which is the study of microscopic objects. Now let me just talk about another study. I talked about CM. What is CM? Study of macro. This is study of micro. Now you may be interested in studying the macroscopic objects from microscopic point of view, and that is called the study of macroscopic objects from microscopic point of view, and it is called statistical mechanics. It is called statistical mechanics. It is the study of macroscopic objects from microscopic point of view. Now going back to the Dalton's theory, let's just quickly check it up. Remember that Dalton talked about the atom to be, this is the first one that we're going to take up today. Dalton's atomic theory, which talked about the atom to be a hard dense body. It was like a hard dense body, and it is indivisible particle of matter, and it was considered to be indivisible. The second thing that you can actually note down is that each element has a particular kind of atoms. That means the atoms which are contained in a particular element will all be the same for a particular element, but as we move from one element to another element, we find that there will be a difference. So they had particular kind of atoms. Okay, it used the theory of law of chemical combination. He actually at that time used this, and it was actually believed that atoms are not just indivisible, they are also indestructible. They are also indestructible. These were like just the fine things that you had done before, so just note them in points. And then thereafter we had seen that it was not a very successful model because it could not give an explanation about the isotopes and isobars. Why atoms should differ in valency. So I'm just giving you by and large should differ in valency. So these were the two things which he couldn't answer. Remember that the basic gist of the Dalton's atomic theory was that he talked about the atom to be indivisible and indestructible, and then thereafter he stated that the elements have a particular kind of atoms, and he used the laws which were available at that time, like the law of chemical combination. Apart from it, when you actually do a model, you find out whether all the answers that you were looking for are answerable. I mean, whether it is answerable or not to all the questions which were like coming up. So it could not explain the concept of isotopes and isobar. I hope you remember what are isotopes. Same atomic number but different atomic masses. And what are isobars? Same atomic mass numbers. Alright, and here what we have is he also could not explain as to why atoms should differ in valency. Thereafter, it was actually an experiment that was done by William Crookes, a scientist with the name of Crookes. What he did was he talked about the cathode rays. I'm just telling you the main important things. Actually, how do you study about the cathode rays? He actually generated some kind of rays existing from an element, because atoms knowledge had already been imparted by Dalton. So scientists went on to now do experiments with the atoms which were available. Why different in properties? Because they will look for the answers. What were the questions? Isotopes, isobars could not be explained, and then he could also not explain why different valency. So why the behavior was different. So what he did was he took a gas discharge tube. Gas discharge tube is the one in which you have two electrodes set at a very high potential. So there some kind of rays were generated, and those rays were actually deflected by the positive part. So what they were attracted towards the positive part. So basically it was found that the rays which were generated from the elements at that time which were used for study were nothing but the cathode rays. Cathode rays are they are nothing but a beam of negatively charged particles, and those negatively charged particles were called electrons. Those negatively charged particles were called electrons, and this term electrons was given by a scientist called Stoney. The name electrons was given by a scientist called Stoney. And then J.J. Thompson also did his experiment from where he could actually find out the specific charge to mass ratio, that is the famous E by M ratio. The charges to mass ratio that he could find, and this ratio was equal to 1.758 into 10 to the power 11. What will be the units? Coulomb per kilograms. Charge is coulomb and mass is kilogram. So Thompson gave from his experiment the charges to mass ratio, and thereafter there was the Millikan's oil drop experiment that was done, and from the Millikan's oil drop experiment he actually could find out the charge on an electron, and that charge, all of you all know, was equal to 1.6 into 10 to the power minus 19 coulombs, and the mass of an electron is 9.1 into 10 to the power minus 31 kilograms. See, there is no harm as you're writing, please try and memorize it right here, right now. These are some terms which will be used again and again, and you may or may not be given the values. So please take care of that. Then as these were the negative rays, then the positive rays were also discovered, and these positive rays were nothing but they contained a stream of positively charged particles, and these particles were called protons. Protons were discovered by Goldstein, and the mass of the proton was found to be equal to 1.6735 into 10 to the power minus 27 kilograms. Fine. And then after that, basically Thompson's model had come up. That's the simplest model that one talks about. So let's just talk about it. Thompson's model was nothing but it was a plum pudding model where it was believed that the positive charges are like distributed all over your atom, and you have the electrons which are embedded within it. Say like you have a positive charge, which is like, if this is your atom, it was believed that the positive charge is spread throughout this atom, and somewhere in the in some spaces you have the electrons embedded. So it was called a plum and pudding model. That is why it was called a plum pudding model. This was the Thompson's model that was given. Clear? And please remember these things because they came up slowly, steadily, and the contributions from each and every scientist is important. First, Crookes actually studied the cathode rays, which were nothing but a beam of electrons, and that term was coined by Stoney, and the charge on an electron is 1.6 into 10 power minus 19 coulombs. Units are very important, and the mass is 9.1 into 10 to the power minus 31 kgs, and your charges to mass ratio is 1.758 into 10 to the power 11 coulomb per kilogram, right? And then you had the positive rays also being discovered, which was nothing but a beam of protons. Protons are the positively charged particles. So protons were discovered by Goldstein, and you had the mass of the proton as 1.6735 into 10 to the power minus 27 kilograms. And then you know about the Thompson's plum pudding model, which was nothing but in which it was like considered, because now positive rays were also found to be emitted from the elements, and negative was also emitted. So it was like quite not that easy, but then he must have researched upon it to state that you have an atom which has positive charge all throughout and negative charge which is like embedded. So it was like kind of a plum pudding model till you had the Rutherford's model, which was given. So what did Rutherford do? Rutherford's model was actually just talking about, say, a beam of electrons. He actually generated alpha particles. You know that? He used a beam of alpha particles, and then they were like made by thin, these alpha particles were made by thin metallic foils, and then they were made to bombard on a thin film of metal foil. It was made to fall on a thin metal foil which was around 10 to the power 4 atoms thick. You now know what do we mean by the number of atoms, which was about 10 to the power 4 atoms thick. So here in this case, what was actually were the findings of Rutherford? Let's talk about the observations. Okay, he generated alpha ray particles. So alpha rays, which comprised of the alpha particles. Remember that when I talk about a proton here, proton is generally your 1H1. You know that? Where this represents the atomic number and this represents the mass. And when I talk about the alpha particles, you should also know that I am talking about helium atom now. Here in this case, alpha particles are represented by 2He4. Okay? Alpha particles are represented by 2He4. So now the observations that Rutherford found when these particles were made to bombard on a thin metal foil were like most alpha particles just passed, simply passed, you will say undeflected. They simply passed in an undeflected manner, simply passed straight away. So what does this imply? This implies that because for every observation you need to have a reason. If I am putting the metal foil here and I am making the alpha particles fall on it, which are like positively charged particles in one sense, what was happening? They were just simply passing through. So this implies that majority part of my atom was empty. It was found at that time that majority of this space in atoms is found to be empty. Then it was found that some of them were deflected by small angles, some got deflected by small angles, and very few, very few in fact, got deflected by large angles, and some even to the extent of 180 degrees. So 180 degrees means that they are just retrieving their path back. If they are falling like this, then they will just go back through the same. So that means there is something which is in the middle of the atom which has the same charge almost as yours. So they would like charges repel each other, so they got completely deflected. And you had some so that means this sum and sum, what does it mean? That majority, most of them were undeflected, means majority of the space in the atoms is like empty, and you have some deflections by small angles and some by very few by a very large, means that you have a small concentration of some positive charge in your atom. Got it? You have a small concentration of the positive charge in your atom, and therefore the conclusions that he made were like, you can actually draw conclusions simultaneously. What were the conclusions? The first conclusion was that because they were like, you talk about the empty space, majority of the atom has empty space, then you have the alpha particles which are getting deflected, so that means there is some positively charged body inside. And if it is getting deflected by a very large angle, that would mean that there is some charge which is very high, which is sufficient enough to repel, because alpha particles are heavier. So some positive charge which is concentrated, which is very high charge, high positive charge, which is concentrated in a very small region, charge concentrated in a very small region, and that is known as that was called a nucleus. Okay, now here when we talk, so this was by and large your Rutherford's model revised. In Rutherford model, basically what was actually given, that there is a nucleus which has a thin population of electrons around it. Electrons were found to be moving around it. Now the problem with the Rutherford model was that he could not explain the most important thing, that was the stability of the atom. That means that if you have a nucleus in the middle and if you have the electrons revolving around that nucleus, then in that case you know that the electrons as they move around will tend to lose energy. And if the electrons tend to lose energy, then in that case what will happen? They will ultimately collapse to the nucleus. That means according to Rutherford, the model that he had proposed, he could not explain as to why the atom is like a stable entity. Atom is stable after all, nothing is getting destroyed around us on its own unless and until some force is provided to it. So he talked about the nucleus, there was electron around it, and he talks like, he actually talked about the thin population of electrons around it, but the problem was like he could not explain the stability. You understood why? Because the electron is expected to lose energy and ultimately fall to the nucleus, but that was not happening. And secondly, he could not even explain the spectra. He could not explain the spectra, means spectra which is giving rise to the colors and all. So basically when we talk about the spectra, let me just explain when I say spectra, because one of the major drawbacks of these models was that they could not explain the spectra. And say if I am talking about different energy levels, please understand this concept. First of all, when I am talking about classical objects, then I know I am talking about continuous form of energy. Why continuous form of energy? Because in classical you have the energies levels so closely placed, the energy levels are so closely placed that you can have just a continuous way. Got it? In this case, the energy levels are so closely spaced that you can just have a continuous way. Whereas in quantum you have different energy levels. Now when you talk about these energy levels, they are like you are talking about subatomic things. So here the subatomic particle is an electron. So you have one level here and another level here. Understood? You have different levels, and what is occupying that energy, what is occupying that energy levels? Those microscopic particles only, microscopic entities that we are talking about, and one of them is an electron that we are talking about. So say an electron is sitting at this energy level. When this electron jumps to a higher energy level, please understand this because you're doing it for the first time. When this electron jumps to a higher energy level, it needs energy. So it will absorb certain amount of energy. I repeat it again. Say, when I talk about, say, what are these? These are the quantum levels, because I am talking about discrete energy levels. So if I am talking about, say, an electron is occupying this particular energy level. If it jumps from this level to this level, it will absorb energy. That will correspond to, if I draw a plot between intensity, you know, a graph can be plotted. Intensity means what is the intensity of radiation, how intense or how less intense. I mean, that's like kind of an intensity parameter. And here you have the energy. If I talk about the intensity versus energy, then in that case, that will correspond to some energy that it has absorbed. It will absorb some minimum amount of energy. That energy can be plotted, and this energy is going to give you information about the spectra. Say supposedly, if this energy corresponds to somewhere in the visible region. Visible region is like a range of electromagnetic radiation. Just understand this. When it jumps from lower level to higher level, what happens? It absorbs energy. So it will correspond to absorption spectra. This you can understand. And now when it will jump back to the ground state, now it will emit energy, and this will correspond to your emission spectra. So basically you get information about the spectra in that fashion. So this is something which is known as a part of spectroscopy, because spectroscopy deals with the interaction of matter with electromagnetic radiation. There is another branch of science that we will talk about in a small fashion here, that is spectroscopy, and that is the branch of science that deals with the study of interaction of electromagnetic radiation with matter. Okay, now what was the last model that we did? That was the Rutherford's model, and after Rutherford's model we had basically talked about the spectroscopy that I just gave you, and that corresponds to, say, let's talk about the electromagnetic spectrum. This is an important thing that needs to be done. Electromagnetic wave or radiation, it is not a single wavelength, but it's a mixture of various wavelengths. But before that, you should understand what is a wavelength also. We talked about discrete packets. So I did tell you that Planck gave his quantization concept, and he stated that energy can exist only in discrete packets. This H is your Planck's constant. This H is your Planck's constant, the value for which is 6.626 into 10 to the power minus 34 joules second. And this is known as the frequency. This is known as the frequency. And remember that this nu is equal to C upon lambda. This nu, that is the frequency, is equal to C upon lambda. Again, you should be able to qualify each expression. What is your C? It is the speed of light, and what is that equal to? 3 into 10 to the power 8 meter per second, right? And this is your lambda, which is the wavelength. Also remember here at this point only that your 1 upon lambda is called the wave number. 1 upon lambda is given a term which is known as the wave number. That's represented by a nu bar. And the units of wave number will be meter inverse or centimeter inverse. What will be the unit of frequency? It is meter per second by hertz per meter or centimeter, or the general term is like per second. And then here you have, I've already given you. So please, this is like the simplest concept that you've done, and you can easily do that. Now in electromagnetic spectrum, when I am talking about it, it corresponds to the different energy levels. You have different ranges of energies which are existent in the universe. And when you talk about the electromagnetic radiation, they are arranged, I am just arranging them in the order of, say, increasing wavelength. So the wavelength is increasing in this direction. And please learn it up because this is very important. You have cosmic rays, gamma rays, X-rays, cosmic rays, gamma rays, X-rays. You have UV, visible, IR, microwaves and radio waves. These are the ones which constitute your electromagnetic spectrum. Your wavelength is increasing in this direction. Wavelength has a particular value. And if you are given the wavelength, you can easily calculate the energy, because this energy will also be equal to hc upon lambda. Right? This energy is also equal to hc upon lambda. H is a constant, c is also a constant. So here itself, if I have to calculate in terms of electron volts, let me tell you in terms of electron volts, if you have to calculate in terms of joules, you can use these values. If you have to calculate in terms of electron volts, this constant and this constant will be equal to 1240. 1240 upon lambda electron volts. So please remember this, that the energy is equal to 1240 upon lambda in electron volts. Now let me just talk about the wavelength here. For the visible special one, this is like 3800 to 7600. Now just understand one concept. Look up all of you all. I did talk about continuous energy levels which exist in your classical mechanics. I did talk about quantized energy levels which are a part of your quantum mechanics. Now when I am talking about the jumping of electron from one level to another level, I am talking about spectroscopy, because I am talking about the energy required. Now say if the energy required falls in the wavelength region within this, if the energy that is required to jump from one level to another level for the electrons or the subatomic particles that we are seeing around us, it falls in this range of wavelength, there will be a certain amount of energy that it will require to jump up or go down. It will emit energy. That energy will correspond to one of these regions only, and according to that we will observe their spectra. According to that, like for example, if you observe whatever colors we can see around, what do you think is the energy that they are possessing? Whatever colors we can see, they are possessing the wavelength in between 3800 and 7600, right? 7600 in angstrom. So what we have is, this is like, it lies in 3800 and 7600. That is why visible range is the one that we can see from the naked eye. So you can observe the different colors of the rainbow. You must have seen the rainbow ever. Have you ever seen a rainbow? So in that you have the regions as VIBGYOR. I mean, you observe these colors. You observe all these colors. So violet corresponds to this wavelength and red corresponds to this wavelength. Did you get it? So anything that goes beyond the range of this color falls in IR, and if the wavelength is less than that of the violet color, it falls in UV and you will not be able to see it. Got it? So whatever colors you are observing around fall in this region. And what is that color due to? That is due to the jumping of these subatomic entities from one level to another level, primarily an electron. Clear with that? So here this is the range which talks about the increasing range of wavelength. So I'll just quickly put the values because they are given in the notes that I have. 0.011, then X-rays is like 150, then you have 3800 to 7600, and this is like 6 into 10 to the power 6, and microwaves is like 3 into 10 to the power 9, and whatever goes beyond this region will be your radio waves. So which are the one which have the highest wavelength? Radio waves. Which are the one which have the lowest wavelength? And if I talk about the frequency will follow the opposite route. The frequency will go on decreasing. Here in this case, UV rays are harmful because they've been found to be penetrating inside our body to cause cancer. So that is why ultraviolet radiations, and they are generally absorbed by the ozone layer. So that's like another part of it. But here what we have is the electromagnetic spectrum. Clear with the electromagnetic spectrum? Let us all speak it up once. It's cosmic rays, gamma rays, X-rays, UV, visible, IR, microwave, radio waves. Say it again. Cosmic rays, gamma rays, X-rays, UV, visible, IR, microwaves, radio waves. One last time. Cosmic rays, gamma rays, X-rays, UV, visible, IR, microwaves, radio waves. Clear? So this is your total electromagnetic spectrum, and I hope that the meaning of the spectrum is like clear to you. So any energy which falls in this region will be observed in the X-ray region only, depending upon the energy which it corresponds to. Electron को jump करने के लिए it needs some energy from the lower level to the higher level, and that energy will decide in which region will you observe the spectra. So this is one concept. And then in spectrum, when we talk about spectrum, you can either have a continuous spectrum or you can have a discontinuous spectrum. What is a continuous spectrum now? Continuous spectrum is the spectrum that you observe from a prism. Prism, you all have seen a prism, or have you observed the rainbow in general? So there you get a continuous spectrum because that's like a range which can be just seen throughout. Violet, indigo, you will see all the colors in a range. So that is called a continuous spectrum. This continuous spectrum is the one, like for example, if you are heating a metal, say an element in a flame generally, then in that case, when you heat elements directly in the flame, then you see flashes of light appearing. That is because of the jumping from one level to another level, but it corresponds to some kind of a line spectra. That's called a line spectra, if you can understand that. It corresponds to a line spectra. So that means you will obtain jumping of an electron, so you will see a flash of light. Then after some time there will be another transition. This is called transition. Jumping of electron from one level to another level is called transition. It's change. Transition means a change. Change from one level to another. So this, so in discontinuous spectra, one example can be that of a line spectra, and that is generally seen when you heat up an element generally in the flame. You get some meaning of it from the top? Say yes if you understood. See, in spectra, sometimes you actually are getting discontinuous spectra means now you will not get. If you are getting, this is like your energy values, okay, and this is your intensity. Spectra is some kind of a plot that you observe. Say if one transition is occurring at this energy, the other may be occurring at the far end at some other energy. This is only a value. You getting? It's only a value. That value is just plotted. Say if it is very intense, it will be plotted like this. If it is less intense, it will be plotted, but it's appearing in breaks. And when you have a continuous spectra, the continuous spectrum goes like something like this. So it's like you are observing transition at each and every point of energy. Okay? And here for energy you have the line spectra. Clear with that? So you have a continuous spectrum as well as a discontinuous spectrum. Then for the Planck's theory of radiation, I have already put down all these formulae that needs to be revised again. You have the energy which is equal to h nu. And h is your Planck's constant, nu is your frequency. Remember the value of the Planck's constant, frequency 26 into 10 power minus 34 joule second. Nu is your frequency, which is equal to c by lambda. C is the speed of light and lambda is your wavelength. And remember, 1 upon wavelength can also be termed as your wave number. So you will require this information. Let's quickly take up a question. Find the ratio of the frequencies of light. Yes. Okay, you understood the spectra. You all have done one electromagnetic spectrum series. I have given you, what is that? Cosmic rays, gamma rays, X-rays, UV, visible, IR, microwaves and radio waves. So now in this case, this is the order of increasing wavelength and decreasing frequency. If wavelength is increasing, then you know of course frequency is, because they are inversely proportional. So here in this case, when I am talking about the jumping of electron from one level to another level, then I am saying that there may be some energy if my electron is jumping from one level to another level. Then it will correspond to, say, some energy difference. It will need energy to jump from lower level to another level, right? This jumping of electron, if it is taking continuously one after another, then when you check out the spectra, it will be like a continuous spectrum, first line, second line, third, and then you will have a continuous spectra altogether. And that is something when you observe a rainbow or the colors from coming out of a prism. They're like in continuation, violet, indigo, there's like no gap and they're like a continuous spectrum. But when I talk about a line spectrum, then in that case, if I talk about an atom or an element being burnt in a flame, then you see flashes of light. It has got nothing to do with the spectrum. When you plot the spectrum, then there is like a discontinuity. Then that means that if you're getting one transition at one point in time, the another transition may correspond to some other energy value. So continuous nahi hai na? They are like distinct from one another. So that is what is called as a line spectra. And this line spectra was the one that could not be explained by Rutherford, as well as, no, Bohr could actually give some justification to it. Line spectra of hydrogen atom is what we will do. Quickly take up a question. I am asking you to find out the ratios of frequencies is like nu. I am asking you the ratio of frequency of violet light to that of red light. The question says that find out the ratio of frequencies of the violet light and red light when the wavelength of violet light is given to you as 4.1 into 10 to the power of minus 5 centimeter, and the wavelength of red light is given as 6.56 into 10 to the power minus 5 centimeter. So you have to find out the ratios of the frequencies. You can easily do that. You know that your wavelength frequency is inversely proportional to wavelength. Frequency is inversely proportional to wavelength. So frequency of red light will be inversely proportional to the wavelength of red light. So that, or you can actually put it like, so therefore nu1 by nu2 will be equal to lambda 2 by lambda 1. They are inversely proportional. Clear? So if you're given the wavelengths, you can easily find it out. So the answer should be, it should be a ratio of 6.56 into 10 power minus 5 upon 4.1 into 10 to the power minus 5. So that's like an easy thing that you can do, and that will be somewhere around the ratio that is given as 1.6:1. You can easily do the calculations later, just understand the concepts. You are given the ratios of the frequency and you are asked the ratio of the wavelengths, right? Then another question, just note it down, 100 watt power source emits green light of wavelength 5000 angstrom. So you are given 100 watt power source emits green light which has a wavelength of 5000 angstrom. How many photons are emitted per minute? So you have to talk about the number of photons emitted per minute. The number of photons emitted per minute. So how will you go about doing it? You know that E is equal to basically h nu, which is equal to hc by lambda, because I am given the lambda, that is equal to hc by lambda, right? Now here the energy that we have is say 5000, power into time is your energy, hope you remember. Power into time is your energy, and that is equal to NH nu or n hc by lambda, because this n is the number of photons. This is your 1 photon and this n is your number of photons. So energy is equal to n into h nu, which is equal to n into hc by lambda. So here energy can be written as P into T, and then you have n is h into n hc by lambda. So your n will be equal to Pt lambda upon hc simply. That will be equal to Pt lambda upon hc. Just substitute the values and calculate the answer quickly. Power is equal to your 5000 into 10 to the power minus 10. Power is equal to 5000 into 10 power minus 10. And then you have your time that you will take will be how much? Is the time given in the question? 1 minute, because you are asked per minute. So 60 seconds. And then lambda is also given to you. Lambda is 5000 into 10 power minus 10. Power is 100, and you know h is equal to 6.626, and your c is 3 into 10 power 3 into 10 power 8. So what is the answer? Just a rough calculation. It will be around 1.5 into 10 to the power 22. It's like an easy question. All you need to do is remember the small tits and bits also that you've done before, because you're dealing with energy, so different formulae that relate the energy should also be remembered. You were asked the number of photons, so please remember the formula of energy as NH nu, which is hc by lambda. So if lambda is given, you can calculate energy. Now that power was given, you were supposed to just multiply it with time to get the energy in joules. Then we move on to the next concept of the photoelectric effect. I've already told you the history, so you know the importance of all these concepts. Remember that photoelectric effect is nothing but it is the phenomena of ejection of electrons from the metallic surface when light of certain frequency falls on it. Now there are some important points related to the photoelectric effect. In photoelectric effect, the very first thing, there has to be some minimum amount of frequency that has to be provided, and only after that frequency is provided you will have ejection of electrons, which is known as the concept of threshold frequency. If you are talking about frequency, means automatically threshold energy, because this frequency will again correspond to your energy. So either some books talk about threshold energy, some minimum amount of energy after which electrons will start getting ejected from the metallic surface, or some minimum frequency after which. It's like one and the same thing only. Why? Because you know frequency and energy are related to one another. Then the second thing is that that you need to remember is that the kinetic energy of ejected electrons. The kinetic energy of the ejected electrons is independent of intensity. Remember, it is independent of intensity. Why am I specifically laying emphasis on it? Because it was actually found earlier that Maxwell's concept stated that the kinetic energy was dependent on it. So this was kind of a violation. So it was found here that the kinetic energy of the ejected electrons is nothing but it is independent of the intensity and is dependent upon what? And is directly proportional to the frequency of the incident radiation. The number of electrons ejected depend upon the intensity. The number of ejected electrons, they depend upon the intensity of the incident radiation. One last point for the photoelectric effect is that there should be no time lag between the incident radiation and the ejected electrons. There should be no scope of any time lag. Means that the moment the radiation hits the surface, there should be an ejection of electron instantaneously. Exactly at the same point in time, you should just have an ejection. The moment it strikes the surface, there should be an ejection of electron. Okay, so photoelectric effect has some 4 important points. One, threshold frequency. You all understand the meaning of threshold frequency. It's the minimum frequency which is required for the ejection of electrons to take place. Then the second thing is that you have the kinetic energy which is directly proportional to the frequency of the incident radiation. Then you have that the number of ejected electrons will depend upon the intensity. So both these points were a violation of the earlier theories. And then the fourth point was that there should be no time lag between the incident radiation and the ejected electrons. That is because it was like conditioned that the photoelectric effect is observed in that fashion only. That there should be no time lag, because if there is a time lag, then there may be other energies which will be creeping in. So you're just not talking about just the incident energy which is provided. Okay, now say there is like the total energy which is like provided, and you know some of it is getting converted to the kinetic energy of the ejected electrons, and there is some energy which will be left, and that energy is known as the work function. That energy is known as the work function. So what you have your this work function is again nothing but this equation is known as the Einstein photoelectric equation. This is the total energy that is provided. What was the total energy that we provided? That was h nu, where nu is your frequency which is either equal to or greater than the threshold frequency. Kinetic energy means half mv square, and your work function is the energy which is left over, which will again be directly proportional to the frequency only, and that is some h nu naught. I repeat it again. Here what we have is that the initial energy is equal to the kinetic energy plus the residual energy. This was like kind of, you can actually call it the work function. Work function because it is only after this energy has been utilized by the molecules that they are now getting ejected. And the electrons which are getting ejected also have some kinetic energy. So remember that this equation is important, and here you can write down kinetic energy therefore will be equal to h nu minus h nu naught, simple rearrangement, which will be equal to h into nu minus nu naught. This implies that half mv square is equal to h into nu minus nu naught. So quickly just revise the photoelectric effect once again. In photoelectric effect, what have we seen? In photoelectric effect, we are just revising this only. In photoelectric effect, we are talking about the ejection of electrons from the metal surface when a light of certain radiation falls on it. So the moment you think about photoelectric effect means it's talking about ejection of electrons, and those electrons, if they're getting ejected, have some kinetic energy also because they're moving out. Okay, so there are 4 important points. The first point is that of threshold frequency. That means that there needs to be some minimum amount of frequency or energy that needs to be provided, only after which there will be ejection of electrons. The second point states that now the kinetic energy of the ejected electrons, the energy with which the electrons are moving out, is directly proportional to the frequency of the incident radiation. Okay, they are dependent upon the frequency and not the intensity. The earlier classical mechanical theory stated, like for the electromagnetic radiations, was found that the kinetic energy was actually dependent upon the intensity, which was like now ruled out here. So you have the kinetic energy to be directly proportional to frequency, that you can actually linear dependence you can already see here. Then you have number of ejected electrons as to how many electrons are directly proportional to the intensity. And the fourth one is like there should be no time lag between the incident radiation and the ejection of electrons, right? And then you know that the equation that will be formed from the photoelectric effect generally is that the total energy that you are providing will be equal to the kinetic energy plus some extra energy which will be the work function, and that will be like h nu is equal to half mv square plus h nu naught. Clear with that? This nu naught may or may not be equal to the threshold frequency. Generally you can just say that some amount of frequency was, the energy was like used up by the molecules, by the electrons, and then they just used up that energy and they got ejected. So the totality, in totality the total energy is nothing but equal to the total energy that was provided. This total energy is now we rearrange the equation and we get that the kinetic energy is equal to h into nu minus nu naught. From here also you can see that the kinetic energy has a dependency on frequency itself. Okay, so we'll just see if we have any questions related. See, threshold frequency will be the frequency that we are actually initially providing. So that will be a part of the total energy only, because if on the metal surface, that should be greater than or equal to. एक minimum energy चाहिए. Say supposedly if I randomly talk of that I need some 100 joules of energy to pull you out. So अगर मेरे पास 80 joules of energy होगी, I will not be able to pull you out from the chair. But only if I have 100 joules or more, I will be able to replace you. Got it? Then you can just take up a question quickly. Calculate the velocity of electron. So you ask the velocity of electron. So just write down the unknowns quickly. From the platinum surface, whichever surface, it can be asked any surface, when radiation of 200 nanometer, so you given the wavelength, falls on it. I repeat, calculate the velocity of electron. Calculate the velocity of electron. So you ask the velocity of electron when you have the radiation, when it is ejected from the platinum surface, when radiation of 200 nanometers, radiation of 200 nanometer falls on it, and the work function is given to you. The work function means you are given h nu naught of the platinum surface, which is equal to 5 electron volts. Work function is equal to 5 electron volts, and here itself I'd like you to remind you of the conversion that 1 electron volts is equal to 1.6 into 10 to the power minus 19 joules. Okay, you have to solve this question. So now using the Einstein's photoelectric effect, here we have that total energy will be equal to kinetic energy plus the work function, right? Now what is your total energy? The total energy is equal to hc by lambda, that's h nu. We are given lambda, that is why I am taking lambda. The lambda is given as 200 nanometers. Now because I have this in electron volt, I have an easy formula for electron volts. What was that? 1240 divided by lambda. So I can actually use that here. 1240 divided by 200. That is like a quicker method. 1240 divided by 200, and that will be equal to, you can easily see that, 6.2 electron volts. This work function, so I calculated the initial energy because I was given the wavelength. I repeat the question once again. The question states that calculate the velocity of electron ejected from the platinum surface when radiation of 200 nanometers falls on it. So this 200 nanometer talks about the incident radiation. So that is the energy that is supplied. So this energy of 200 nanometers is used to calculate the total energy, which is equal to 6.2 electron volts. This is clear to everyone, and we have been given the work function. So from here, now what do we have to do? We are given the work function. We have to calculate the velocity. Velocity is contained in which formula? Kinetic energy. So that is equal to half mv square, and we know that that is equal to h nu minus h nu naught. That means the initial energy, sorry, I'll put it like this, otherwise you'll get confused. This is the initial energy minus the work function. What is the initial energy we've calculated? That is 6.2, right? That is 6.2 minus 6.2 minus 5 electron volts. Now when you've simplified, you can easily convert it into joules also. How will you convert it into joules? 1.2 into 1.6 into 10 to the power minus 19 coulombs, and you know that that will be 12.6. So you have 72, and then you have 1.94 into 10 to the power minus 19 joules. And from here you can easily calculate velocity, that will be equal to under root of twice of kinetic energy divided by m. And what is the mass of an electron? Twice of kinetic energy means twice of 1.94 into 10 to the power minus 19 joules divided by m, which is 9.31 into 10 to the power minus 31. Just substitute the values and quickly solve it. I repeat this question again. We were given the wavelength of the incident radiation onto the platinum surface, and we were asked for the velocity when the work function was provided to us. Work function was given in electron volts, so simple for us. We can easily calculate the initial energy by the formula hc by lambda, that is 1240 divided by lambda, and we calculate our initial energy. Once the initial energy is calculated, I know this now, that is 6.2 electron volt. I know the work function which is given to me, that is 5 electron volts. So I can calculate the kinetic energy. What is my kinetic energy? It is total energy minus the work function, that is 1.2 electron volts. 1 electron volt is equal to 1.6 into 10 to the power minus 19 coulombs. So you can easily convert it, and this joules, joules, to convert it into joules, I'm sorry, that is 1.6 into 10 power minus 19 joules, and you will get the final answer from electron volts and joules by multiplying both of them. And now you know that velocity can be related to the kinetic energy, and velocity is equal to under root of 2 ke by m. This was a simple application of Einstein's photoelectric effect. We can, I think, take one more example. What we have is a photon of light of wavelength 400 nanometer falls on a metal surface. I repeat, a photon of light 400 nanometers falls on the metal surface. So this belongs to what? The incident radiation or EI? Incident radiation. So what we have is lambda is given to us as 400 nanometers. Now, as a result, photoelectrons are ejected with the velocity, that means velocity for the photoelectrons which are ejected means kinetic energy possesses a velocity of the electrons as 6.4 into 10 to the power 5 meter per second. First question is, what is the kinetic energy? Very simple. You don't have to do anything in kinetic energy. What is your kinetic energy? Half mv square. What is your m? 9.31 into 10 power minus 31 kilograms. And you have your velocity as 6.4 into 10 to the power 5, the whole square of that. So that will be giving you the kinetic energy. And the next question is, calculate the work function. Very simple. Work function. Your total energy will be equal to kinetic energy plus your work function. Work function, say W naught. Alright. Kinetic energy you will have calculated from 1. And this energy will be equal to what? hc by lambda. If you want, you can calculate hc by lambda directly, where lambda is given to you as 400, and you can remember this value as 6.626 into 10 to the power minus 34, and c is your 3 into 10 to the power 8. So you can actually remember the total up value also. For the numericals, please remember the total value itself so that you do it quickly. What will that be? Let's solve it here. 18, 3 to the 6, 7, right? 3 6 are 18, 1 and 3 6 are 18, 1. 19.878. So you will have into 10 to the power minus 9. Yes, yes. Please have the SI units intact in your numericals. So in this case, what will you have? You will have either, or there is a shortcut also. This involves the calculations of the powers sometimes. What was the easy way of calculating EI? I told you can easily calculate it in electron volts. 1240 divided by 400 in electron volts. So once you do that, that just has to be multiplied with 1.6 into 10 power minus 19 to convert it into joules. Got it? So this is, I mean, whichever way you find easy. So find out the total energy. You are given the kinetic energy in the previous question you found, and you can easily find out the work function. Clear? Next we come on to the Bohr's model. First understand that the set of visible region lines, I mean, we have basically the hydrogen lines, the spectra, hydrogen spectra could not be understood. In hydrogen spectra has a series of five series of different lines in the spectra. Those series are, I'll tell you, those series are like, you have Lyman, Balmer, Bastian, Brackett and Pfund. And you have Humphrey also. These were the 5 series of lines which were observed for the hydrogen spectra, hydrogen line spectra. And remember that out of these, the Lyman lies in the UV region, Balmer lies in the visible region, and the rest of them lies in IR. So now you can understand somewhat. We had done the electromagnetic spectrum, cosmic rays, X-rays, cosmic gamma, X-rays, UV, visible, IR, and then you had microwaves and radio waves. So in this, just understand that you get a series of lines which are like in this order. So you can see that that order is like the least wavelength and the highest wavelength. So you have UV, visible, IR, and Lyman series exist in the UV, Balmer in the visible range, and Bastian, Brackett, Pfund and Humphrey all are like beyond the visible, so that is in IR. So we will be studying about these, but the only thing that you can do right now is that this, yes, these are the series of lines which are found, and they are found that the energy required for the transition in this case will correspond in those regions. You remember you had written the wavelength on top of the electromagnetic spectrum? You had written wavelength. Look into the electromagnetic spectrum that you all have written. I gave you the wavelength range. Okay. Now if the jumping of the electrons from lower level to higher level, from one level to another level, corresponds to a particular wavelength, say in between 3800 or 7600, then that will fall in the visible region only. So it was found that the energy required or the regions in which they are falling is this. Now the reasons had to be given, or the spectra could not be explained. So I mean, let's talk about the next model that was given first and then take it up in details. The next was like, let's talk about the Bohr's postulates. Note down the Bohr's postulate that he actually defined stationary states of motion. He defined the stationary states of motion, which are known as the energy levels, or sometimes called orbits also, which are known as the energy levels. So he talked about the stationary states. States of motion. Alright. Then he did talk about the angular momentum being quantized, because you remember what was the drawback with the previous model of Rutherford? It could not account for the stability, but he stated that when the electron is revolving around the nucleus, the angular momentum with which it is moving is quantized. Quantized means for every level the angular momentum is different. So in this case what you have is, this stated that the angular momentum of an electron, the angular momentum is what? It is represented by mvr. What is the formula of the angular momentum? It's mass into velocity into the radius. So mvr, that is equal to an integral multiple. An integral multiple means it can either be 1, 2, 3, 4, 5 and so on. It is equal to an integral multiple of a factor, that is h upon 2 pi. I hope you remember that. How do you get the angular momentum? The angular momentum is equal to the moment of inertia, that's equal to the moment of inertia into the angular velocity. Now what is your moment of inertia? That is equal to mr square, and what is your angular velocity? That is v by r. So here in this case you get the formula as mvr. This is like something that you must have done before. So we're just talking about it, that Bohr stated that the angular momentum of the electron is quantized. So you get that he was also referring to the concept of quantization. Bohr was also referring to the concept of quantization. Okay, and then he also stated that, now Bohr, what was the difference in Bohr's model? He talked about a nucleus, he talked about the orbits around the nucleus, and he actually stated that the angular momentum is quantized. So the electron will keep moving with that angular momentum, which is like the quantized angular momentum. So unless and until it jumps, there will be no change in the energy at all. Another thing that he stated was that as long as the electron is sitting on one orbit or one stationary state, that's energy level, it will neither emit nor absorb energy on its own. It will not do any kind of a change unless and until there is a transition that takes place. When it needs to jump from a lower to a higher level, you know it will absorb, and when it jumps from a higher to a lower level, you know it will emit out energy. Okay, and then after that you can just mention a point here that there will be the energy difference. The energy required to jump from one level to another level will be nothing but the difference in the energies of those two levels. Say if I want to make the electron jump from one level to another level, the difference between the two energy levels will give me the energy that is required. Simply, if I want to make it jump from this level to this level, I'll find out the energy of this level, I'll find out the energy of this level, and the difference of these two energies will be the energy. So it is not the concept of like the threshold frequency that you provide a little bit extra or a little bit less. So here in this case you will actually find out the difference between these two energies, and that difference in energies will be a product, will be an integral multiple of the quanta. Getting the point? The energy required for an electron to jump from one level to another level will be the difference in the two energy levels. Say if supposedly there was another energy level, E3. So if I want to make the electron jump from E1 to E3, what will be your delta E? It will be E3 minus E1. This is easily understandable. Now this energy may be some value, and that value will always be quantized. That value will also be always quantized. That means some integral multiple of the quanta. And you have mvr is equal to nh upon 2 pi. You can also note down here the velocity of the Bohr's, the velocity of an electron. I am straight away giving you the formulae so that you can remember them for the numericals. Velocity of an electron in Bohr's orbit, that is given by 2.18 into 10 to the power 6 z upon n meter per second. Otherwise the formula is 2 pi k into kZe square divided by NH, where K is equal to 1 upon 4 pi epsilon naught. Just look up. This formula can be easily memorized. What is the velocity of an electron? That's 2.18 into 10 to the power 6 Z upon N. Meter per second are the units of velocity. Now, what is the Z? It is the charge. It is the charge of the atom that you're talking about. For hydrogen, what is the charge? 1. For helium, it will be 2, and so on. So, this Z refers to the charge. N refers to the nth level. Whether you're talking about the first level, second level, third level, first orbit, second orbit, third orbit. So, N refers to that number. And otherwise, the formula is 2 pi K into Ze square upon NH. Now, let me just explain. Pi is a constant, you all know. This K is equal to 1 upon 4 pi epsilon naught. And Z is again the charge. E square you know is your charge on an electron. N is that quantized number that we are talking about, and H is the Planck's constant. So Z by N is like the factor. All the rest of them are a constant. So that has been clubbed together to calculate 2.18 into 10 to the power 6. And one concept that was used to calculate this velocity, if you can get it, please lend me your ears here. One law that has been used, one is like the quantization of the angular momentum that we have used. Another law, if you can just understand, is like the Coulomb's law. This you will be doing in electrostatics and physics next year, but then if you can understand it right now, Coulomb's law talks about the force that is acting between any two charges. Say I have two charges, Q1 and Q2. If I have two charges, then the force that is acting in between these two charges, it will be either attractive force, repulsive force, or whatever force, will be directly proportional to the product of these two charges and inversely proportional to the square of the distance between them. Okay, and when you remove this proportionality sign, you will introduce a proportionality constant, and that is equal to 1 upon 4 pi epsilon naught, which is termed as K here. 1 upon 4 pi epsilon naught. And you have here, because you are talking about E and the other is also E. In chemistry, we are like focusing on the electron majorly. So you have one charge also as E and the other charge also as E. So in that case, we just take it as E square, and then they're like compared, and then finally we arrive at it. I'm not going into the derivation, but just giving you that Coulomb's law was also used to calculate this. Another important term which is important here is the radius of nth orbit. The radius of nth Bohr's orbit, and that is equal to 0.529 into 10 to the power minus 10 n square upon z square meter. The radius of the nth Bohr's orbit, the radius of the nth Bohr orbit is 0.529 into 0.529 into 10 power minus 10 n square upon z square, where now you know your n refers to the level, z refers to the charge, and this is like a combination of various constants. So don't worry about memorizing this formula, rather you can just remember this. Okay? And if I talk about in angstroms, then this will be simply 0.529 n square upon z square angstrom meter. If you talk about the units in terms of angstrom, that takes care of the angstrom meters, that will be equal to 0.529 n square upon z square. And if it is nanometers, then it will be 5.29 n square upon z square nanometers. And you can just bring about those changes. Another very important thing here that he found, I'm just putting it here, is the energy of the hydrogen atom, which he could actually find out correctly. The energy that he could find out correctly, and was found again by Schrödinger. So this energy, you can just note down the expression, but there is no need to memorize it. 2 minus 2 pi square k square me e to the power, me means mass of the electron, so I'm just writing it as m, e to the power 4 z square upon n square h square. Now look at the expression of energy. You have 2 constant, pi constant, k constant, e constant, m constant. What is m? 9 mass of electron 9.3 into 10 9.1 into 10 to the power minus 31, and then you have n again is variable and you have h again a constant. So all these constant terms, this can be clubbed together and you will have only z square by n square which will be left. So a combination of all the constant terms yield the result as minus 1312 z square upon n square in kilojoules per mole. I am giving you all the units here. It is also equal to minus 13.6 z square upon n square in electron volts per atom, and is also equal to minus 2.18 into 10 to the power minus 18 z square by n square joules per atom. Now look carefully here. See, basically when we are talking about the concept of quantization, if the electron is revolving around the nucleus, there is a question as to how angular momentum explains the stability. Rutherford had a problem that he could not explain the stability because as the electron is revolving around the nucleus, it will keep on shedding its energy and ultimately what will it do? It will collapse. But that doesn't happen. All the atoms we see, all the things that we see around are stable enough. So that stability had to be explained. So when Bohr introduced the quantum model, he stated that first of all there are specific orbits. Okay, so one thing that he actually stated and just ruled out the any kind of a drawback that somebody else may pinpoint is like he stated that we are talking about specific orbits. Those were called the stationary states. Stationary states means that you have a particular fixed orbit. Okay, so then there he stated that the angular momentum, now the electron if it has to revolve around the nucleus, the concept of electron revolving around the nucleus will come if we talk about the angular momentum that it possesses, and we are saying that this angular momentum will be quantized. So quantized means that when we are talking about this angular momentum, this will have a particular value for a particular level. Say now, what was the angular momentum? mvr is equal to nh upon 2 pi. If I am talking about the first level, the angular momentum that the electron will always possess will be equal to h upon 2 pi. So it remains like that. So it will not ultimately come and collapse at the nucleus. The second point is like if you have the second shell, so 2h upon 2 pi, so it has a particular value. So that explains the stability in one sense. Then if you want me to repeat the Coulomb's law which is generally used, here Coulomb's law is like you have two charges, Q1 and Q2. There is some kind of an electrostatic force between two charges, any two charges. It can either be an attractive force or it can be a repulsive force. This force is directly proportional to the product of these two charges. So that means force is directly proportional to Q1 and it is also directly proportional to Q2, Q1 into Q2. So what we have, we also see that if r is the distance between these two charges, it is inversely proportional to the square of the distance between these two charges. Okay, and when we club both of them, we get that this force is directly proportional to Q1 Q2 by r square. And when we get this, we remove the proportionality sign and introduce a constant k. This is your Coulomb's law. Coulomb's law simply states that the force which is acting between two charges is directly proportional to the product of those two charges and inversely proportional to the square of the distance between them. So this you anyways will be doing in detail next year. So one quick recapitulation of the Bohr's model. Quickly, what do you have? It gave us the energy levels. One thing. These energy levels are the stationary states. It stated that the angular momentum, MVR, is a constant. What is your angular momentum? That was MVR, and that is equal to NH upon 2 pi. This N will always be an integral number, and this refers to the level of the energy level that you are talking about. It can be 1, 2, 3 and so on. Why not 0? If it is 0, then we are not talking about anything. So what we have is when now we are interested in the spectra straight away. So we are interested in what is the energy required for the electron to jump from one level to another level. If it falls in visible region, you get to know about the colors and all. If it falls otherwise, like for hydrogen we had seen Lyman, Balmer, Paston bracket. So we want to know what is the range in which that energy difference is. Now it's saying that if the electron is jumping from this level to this level has a particular energy and this level also has a particular energy. The difference between these two energy levels between which the transition has to happen will give us the energy required for that transition to happen, and that will be equal to NH nu, because we had already seen that what is the energy required according to the concept of quantum theory. What is the energy required for an electron to jump from one level to another level? It will always be a packet of energy or a multiple of the packet of energy. So how do you find out? The difference in energy may be any value, 1260 joules, any value, 1240 electron volts or whatever, any value. That it can be in minus, we'll talk about it. So now when we have the value that we have written for the energy, that value will be an integral multiple of that quantum. This was the only thing. And then we have the formulae and the expressions for the velocity. We can easily find out the velocity of the electron moving in an orbit. That is again dependent upon the n factor. So for each level the velocity will be a particular value. For each orbit, so now you are getting stability kaise aa rahi hai? If the electron is revolving with a particular velocity, for level 1, what will it be? This value into z upon n. So for level 1 it will be, and for a particular atom, say hydrogen atom, it will be 1 upon 1. So it will be this simply 2.18 into 10 power 6 meter per second, right? So then in that case, जब उसी velocity से move करता रहेगा, then there will be no concept of instability at all. It will keep on moving with that. Then we have the radius of the nth Bohr's orbit, and that is equal to 0.529 into 10 power minus 10 n square by z square in meters. And please remember these expressions, especially for the energy, which is very important. What is the expression for energy? That is minus 1312 z square by n square in kilojoules per mole. Remember that this is per mole. This was joule per atom. So in joule per atom, that means this is the energy for one atom. What is that? Minus 2.18 into 10 to the power minus 18 z square by n square. So joule per atom, say if I want for it to be in per mole, I will multiply this with the Avogadro's number, because एक atom के लिए this is the energy. For 6.022 into 10 to the power 23 means it will be that multiplied by this for 1 mole. So that is calculated accordingly. So rather than doing such calculations, it is easy that you memorize these for numericals. Okay. After this, no, it can be from lower to higher or higher to lower. That will just decide how the energy is going to get transformed. The transitions can be either ways. That is why you can either have an absorption spectroscopy or an emission spectroscopy. Okay. Now just go through the Bohr's model quickly. Remember that Bohr model was applicable only to one electron systems. This is a very, very important point, that Bohr could actually account for only the hydrogen atom and similar systems. So similar systems were like He plus, Li2 plus. So in सबका भी explanation Bohr could give. Why? Because all these are one electron system. He has 2 electrons, so He plus will have 1 electron. Li has 3, Li2 plus will have 1. So Bohr model was applicable to one electron systems. And what are the one electron systems? You have the hydrogen atom, He plus, Li2 plus, and so on. Okay, take a question from the Bohr's model quickly, and the question is, determine the frequency of revolution. You have to determine the frequency of revolution of electron in second Bohr's orbit in hydrogen atom. Frequency of, you have to talk about the frequency of revolution of electron in second Bohr's orbit in hydrogen atom. Hydrogen atom means Z is equal to 1. Now you have to find out the frequency. One thing, all the formulae that you know, frequency is also inverse of time period. You remember? Frequency is also, so this is like kind of a different question, that is equal to 1 upon time period. And what is your time period equal to? Your time period is equal to the total distance covered in one revolution. It is, what is time? Distance upon velocity in this case. So what is the distance that is covered by the electron? You tell me. If this is r and it's moving with velocity, so the distance will be equal to 2 pi r. And what will be the velocity? Let's take it as v. So therefore your frequency will be equal to v upon 2 pi r. Okay. Now we have to tell the frequency and revolution. So now here, remember that this is v. So how can we solve it now? How can we solve it? We know it's the second orbit. We had to find out the frequency. Please look at the question again. The question was to find out the frequency of revolution of an electron in second Bohr's orbit. So your n is equal to 2 and you have in hydrogen atom, so Z is equal to 1, but you have to find out the frequency. Now the only information, what were the formulae that we had written? We had written for E, we had written for V, we had written for R, right? So we know that we can find out V and R if Z and N are known. And what have we done? We have found that frequency is inverse of time period, and we know time is distance, total distance covered in one revolution upon the speed or velocity. So in this case, the total distance covered will be 2 pi r in one revolution upon v. So therefore frequency will be inverse of time period, and that will be equal to v upon 2 pi r. So now we can find out v2 and we can find out r2. For the second orbit, you have the ready-made formulae handy with you. So you can just find it out and then you can just mention the frequency. From here, we can also note it down that you know that R is directly proportional to n square by Z. Is that right? R is directly proportional to n square by Z, and your V is directly proportional to Z by n. Is that right? R is directly proportional to n square by Z and V is directly proportional to Z by n. And we have found that therefore the frequency can be written as, or the time period. Time period is dependent upon R upon V. So that will be directly proportional to n cube by Z square. What we have here is, You have frequency is equal to, pay attention here rather than talking. We have frequency, this till here you've understood. We have a ready-made formula for velocity, we have a ready-made formula for the radius. So we can easily find it out, right? So here you have radius, which is directly proportional to n square by z in your formula. You have velocity, which is directly proportional to z by n. So from here we are just actually generalizing the concept for our numericals only, that t, the time period, therefore what was the time period? It was r upon v. It was directly proportional to r upon v. So when we substitute these values, we get that time period is directly proportional to n cube by z square, and therefore frequency will be directly proportional to z square by n cube. So this concept can also be utilized. Say if you have to find out the ratios of frequencies for a particular orbit, so this can always be utilized for that. Okay, now there was a question that can we have the energy as negative, and if at all, then why? What is the meaning of energy? Did you notice that when I gave you the value of energy, the expression for energy, what was that expression of energy? There was minus 13.6 into z square by n square. Okay, that value was given to you. In that you had a minus. What does that minus indicate? Let me tell you. It indicates that the energy is lower than the value of the energy of a free electron at rest. Okay, it just states that the value of energy for an electron, free electron, now outside the atom also an electron if it exists, then the value of energy of that electron is 0. The moment that electron comes into a bound state in an atom, then in that case the energy gets lowered. That means it leads to stability only. One thing is that. Another thing is sometimes you have the energies showing a negative or a positive. Negative refers to attractive, sometimes attraction or the attractive potential, and sometimes when you have a positive value it means a repulsive potential. But the negative, lower the energy of any system, in negative, higher is the stability. You can understand that? And we consider the energy of the free electron. Who had asked that question? I don't know. The energy of the electron, free electron, which is sitting outside the atom, is considered to be equal to 0. So whatever electron exists in an atom, it in any of the levels, it is found to possess an energy which is lower than that value of the free electron at rest. Clear about that? Then we have here, so therefore if I talk about the electron jumping from one level to another level, what was the energy in terms of joules per atom? Tell me quickly, what was the energy in terms of joules per atom for the hydrogen atom, or generally? E was equal to 2.18 into 10 to the power minus 18 z square by n square. Now here, if I talk about the jumping of electron from one level to another level, means that if I am talking about the jumping of the electron from n2 to n1, so then in that case what do I have to do? I have to calculate the difference in the energies, and that difference in energies will be only for n. There will be difference only in n, right? While z will remain the same for a particular atom. हम एक atom में we have different orbits, and in that atom the charge will remain the same throughout. If it is hydrogen, z will be 1 throughout. And now we are talking about the jumping of electron from one level to another level. So that will be simply 1 upon n2 square, was it square, minus 1 upon n1 square. Or if it is from 1 to 2, then you know what kind of a change it will cause. If it is from 1 to 2, it will be n1 square minus n2 square. That thing is clear to everyone? So when we are talking about the energies, you can easily calculate now the difference in the energies like that. And remember that you can easily find out the wave number also. This generalized formula is also given in terms of wave number. What is your wave number? Let me just tell you. If I talk about energy, energy is equal to hc by lambda, one level from n1 to n2. If we are talking about say the magnitude in totality would decide. If you have to go from lower level to a higher level, it leads to destability. So your net answer should be like a positive entity. You getting? From lower to higher level. Your lower level is the ground state. Your higher level is the excited energy level. So as we are going from a lower to a higher excited energy levels, it's leading to destability because it will always like to come back to the initial ground state. So that will be decided accordingly. We'll just take it up in some numericals. What we have is now energy is equal to hc upon lambda. What is this 1 upon lambda now? 1 upon lambda is your wave number. So this implies your wave number is equal to E upon hc. Wave number is equal to E upon hc. So now that you've calculated your delta E as this, now that you've calculated your delta E from this formula, where you had delta E to be equal to, and to 2 it will be 2 minus 1. So you have this will be some constant that will be equal to R into Z square, because this 2.18 into 10 to the power minus 18 is already a constant. That divided by H into C, you know H is a constant, C is a constant, will give you another constant R into Z square into 1 upon n1 square minus 1 upon n2 square. So if I don't put a negative here, then that takes care of what you were talking about. Then it will be 1 upon, if I put a minus, what will it become? 1 minus n2 square minus 1 by n1 square. This R is known as the Rydberg's constant. This R is known as the Rydberg's constant, the value for which is equal to 109677 centimeter inverse. Please remember this value. And remember, if the value is given in joules, which formula is to be taken? If it is given in electron volts, what is to be taken? If it is given in kilojoules per mole, which value is to be taken? So you need to remember those formulae. Okay, next class when I come, I will ask you all those formulae. Okay. So now what we have is, now the wave number is equal to delta E upon hc, and that will be, and your wave number is also what? That is equal to 1 upon lambda, that is equal to rz square into 1 upon n1 square minus 1 upon n2 square. Okay. So from here we can actually take up a question also. Just write down the question, determine the maximum number of lines. Let's just check up. Determine the maximum number of lines that will be emitted, when an electron in hydrogen atom is in n is equal to 6 state and it drops down to the ground state. How many number of lines? Now this is like a very simple question. They are asking that determine the maximum number of lines that will be emitted when an electron in hydrogen atom is in n is equal to 6 state. So that means I have how many states? 1, 2, 3, 4, 5 and 6. So your electron is on the 6th state and it has to come from 6th state to the first state. अब वो jump, it can actually directly jump to 1 by 1 each level. So from the say n is equal to 6 state, it can directly come to n is equal to 1 state, right? This is one possibility. Keep looking onto the board. It's a very simple concept. Another possibility is from 6, it can come to 2, right? Because this will correspond to 1 energy. So 1 energy means 1 line on your spectra. Plot करोगे तो जो भी उसकी वैल्यू होगी वहाँ पे आप एक लाइन बनाओगे. So that will be 1 line. 6 to 2 is another possibility, लेकिन where does it have to jump? Finally to 1. So then that means 2 say it will come to 1. 15. So then from here 6 it will come to 3. Now from 3 it will come stepwise. So it will come from 3, it will come to 2, and then from 2 it will come to 1. Fine. Then from 6 it can also go to 4. Right? 4 to 3, 3 to 2, and 2 to 1. Finally it has to reach at 1 only. So these are the various possibilities which have to be taken into account, and you have to tell how many lines do you expect, the maximum number of lines that will be emitted. And then you have 6 to 5, that's the last option, because it will not jump wherever it is sitting to just go stepwise. So 6 to 5, there will be like 5 to 4, 4 to 3, 3 to 2, 2 to 1. So count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 lines. Got it? It's a simple question for you to understand that now we are talking about some kind of spectra. Why? Because we are trying to talk about the jumping of an electron from one level to another level. What is that delta E equal to? That delta E is equal to 2.18 into 10 to the power minus 18 z square into 1 by n2 square minus 1 by n1 square, or else it becomes, or else when you take it in centimeter inverse, that when you talk about the wave number has now a new constant. And what is that constant equal to? The Rydberg constant, that is equal to 109677. Fine. From here we can talk about quickly the spectra that is observed for the hydrogen atom. Say for they will not give you a very big question related to it. It is only a concept that how you understand. You know that when it has to jump, there are various possibilities of jumping back, and that is what your hydrogen spectra is all about. One good thing about the Bohr's model was that he could explain the hydrogen spectra. Let's quickly talk about the hydrogen spectra. First of all, we know that we obtained various lines. What are these lines? These lines are nothing but your energy levels. Right, when your energy is equal to, let me talk about in terms of electron volts. If I talk about the electron volts when n is equal to 1, what is the energy of the ground state? In electron volts, minus 13.6 z square upon n square. Please do not forget, minus 13, what is it? Repeat it after me. Energy minus 13.6 z square upon n square. Repeat it again. So then in that case, if I talk about the ground state of the hydrogen atom, Z is 1, N is 1. What will be the energy in electron volts? 13.6. What about N is equal to 2? It will be divided by 4. So that will be equal to minus 3.4. Then the next will be 1.51. The next will be, I'm just putting up, the energy levels are also coming closer. I mean the gaps will be accordingly. So minus 0.85, and then you have minus 0.54, and then you have, I think that's enough. How many lines have we drawn? 1, 2, 3, 4, 5. Let's just work out from this. Now out of these, understand the Lyman series, because he could give the correct explanation, means he could explain the spectra that we were getting. For Lyman series, which was observed in which region? UV. Lyman was observed in UV region. Everything that lies above in different energy states will come down to n is equal to 1. You get that? In Lyman series, your first level, everything wherever the electron is situated, whether it is situated in the second level, third level, fourth level, fifth level, it will always come down to the first level. Okay, so you will have different lines as coming from n 2 to 1, coming from 3 to 1, it will be coming from 4 to 1, and it can also come from 5 to 1. Something like this. So this will represent your Lyman series. You understand this? And remember, the first transition, the lowest of the transition is known as the alpha transition. Then the difference of two energy levels is known as the beta, gamma and so on. Yes. Yes. So this energy gap is less. That is because according to the formula that we have quantitatively calculated, what is the formula that we have calculated? Minus 13.6 z square upon n square. Now whichever value of energy that we talk about, that value of energy will always be corresponding to this value. Minus 13.6 z square upon n square. First level है तो accordingly, second है तो accordingly. और इसका एक और चीज़ बताती हूँ कि when we move to the higher levels, the energy gap keeps coming closer and closer. जब वो एकदम बिल्कुल पास में आ जाएगा तो then what will you talk about? Quantum mechanics getting converted to classical. So this is another concept that is done. So the energy levels keep coming closer and these expressions have been quantitatively calculated. Okay? Now coming back to this. Please, sometimes when the doubts are like out of the frame, you can take a step to relax if at all. Just relax and listen. Now we come back to this. Lyman series is like that series in which all the electrons from different levels will jump down to which level? One level. We can write down the value of wave number also simultaneously, and in this case it will be rz square. They are coming back to the first level. So 1 by 1 square minus 1 by n2 square, because my n1 is 1. Now you get it, minus is taken care of. When I am talking about the jumping of higher to the lower level, so the difference in the energies will be taken care of. So you have, please remember the formula. It's jumping from the higher to the first level. So you have the higher levels will be in n2, n2, n3, n4, n is equal to 2, n is equal to 3, n is equal to 4 and so on. So your wave number is equal to rz square into 1 upon 1 square minus 1 upon n2, whichever level. So that will correspond to all lines in my Lyman series. मान लो the lowest of which will be, what will be the lowest energy in this case? From second to first. That will correspond to your alpha transition. That is from second to first. So if you are asked the lowest possible energy, then you just don't have to think about anything. Just talk about the next higher level and the lowest level. For Lyman series, what is the bottommost level? It's 1. For Balmer series, what you have is that wherever the electron is situated, it will always jump back to the second energy state. So there you will have the spectra shown like this, that it's coming from 3 to 2, 4 to 2, 5 to 2 and so on. And so you can write down the expression yourself. There nu bar will be equal to rz square. You know r is the Rydberg's constant, 109677 centimeter inverse. Z is 1 in case of hydrogen. 1 upon 2 square minus 1 upon n2 square. And this, in this case, the lowest energy will be 1 upon 2 square minus 1 upon 3 square. And then I will just talk about the rest series and move ahead. Then you will have the Paschen series where your N1 is equal to 3. Then you have bracket where N1 is equal to 4. And then you have P fund and you have Humphrey also, and then you have many more. So you can just talk about, because here there is no restriction on the jumping back. So there is no restriction. So you will have the jumping back from different energy levels to the ground state level. So you get the spectra actually came up like this. And what are the series of the spectra? It could now be understood from the energy differences. Because what did Bohr do? He calculated the various expressions of energies. Now we could understand that why the spectra is observed at a particular energy level. Because the energy levels could now be calculated. You calculate the energy difference and check in the spectra, you will get a line at that particular region only. Fine. So remember that the various series of hydrogen atom are Lyman, Balmer, Paschen, bracket, P fund. Take up a question. The Lyman series of hydrogen spectrum can be represented the Lyman series of the hydrogen spectrum can be represented. They are giving another expression now, so that is why I just took up this question. Now for frequency, the Lyman series they are saying can be represented as 3.28 into 10 to the power 15. You tell me what will be there inside? 1 by Lyman series, 1 by 1 square minus 1 by n square, n2 square, whichever higher level, and frequency, so it's given in second inverse. You have to calculate the maximum and the minimum frequency. Calculate the maximum frequency which is possible and calculate the minimum frequency. Now look up, I'll just tell you the methodology. I am giving you this question because I want you to memorize this expression as well. All are simple because in the interior you know it's proportional to z square upon n square. But these constant terms, if you remember, it will help you a great lot for your entrance examinations. So here what we have is frequency is given by an expression of 3.28 into 10 power 15 into 1 upon 1 square. Why? Because we are talking about Lyman series, minus 1 upon n square. Now maximum frequency will be when you have the maximum energy difference. And the maximum energy difference will be when your this level will be some infinite level. So that will be simply, you've calculated the answer. What is the maximum frequency? 3.28 into 10 to the power 15. Okay, and then for the minimum frequency, that will be the minimum difference, the first level. So that will be where n will be equal to 2. It has to come back to one level. So the very simplest of the transition that is possible is from 2 to 1. Got it? So this is like a simple question that can be tackled easily. So remember all the series of hydrogen atom and repeat it once for me. What is it? It is Lyman, Balmer, Paston, Brackett, Pfund. Take up another question quickly. The wavelength of second line in Balmer series of hydrogen atom. I repeat, the wavelength of second line, second line is also known as which line? Beta line. Lines are like first, second. So if I am talking about the second line means I am talking about 4 to 2. Getting the point? Balmer series mein what is the first line? 3 to 2. What is the second line? 4 to 2. So that of hydrogen atom, you have to tell the wavelength. Answer is given. So what you have is simply, let me tell you the answer is given in, you calculate the delta E. What will be delta E? It will be 13.6 into z square into 1 upon 2 square minus 1 upon 4 square in electron volts. This I can calculate in electron volts. And what are they asking? They are asking for wavelength. So what is your wavelength? Wavelength will be equal to Hc upon delta E. Delta E is equal to what? It is Hc by lambda. So your wavelength will be equal to Hc upon delta E. Acha, what is the benefit of calculating this delta E in electron volts? Whatever value I get in electron volts, I can calculate Hc here. What is my Hc? 1240, 1240. So you can easily use that and use it in electron volts. And then whichever units are required, you can calculate it. Please remember just the methodology. So now you have the direct formula with you. You just have to keep putting the formula and the understanding should be clear. The first line is alpha line. So you know for Lyman series it is 2 to 1. Beta line is 3 to 1. For say if I talk about Paston, tell me the alpha and the beta line. For Paston, Paston series, the lowest level is 3. Lyman, Balmer, Paston. So it will be 4 to 3 is your alpha, 5 to 3 will be your beta. You can see in the diagram also. please have an understanding clear that the lowermost is 3. So you cannot talk about coming to 1. Coming to 1 means you are talking about which series? Lyman series. Coming to 2 means you are talking about Balmer series. And then coming to 3, Paston, and so on. Quickly take up the drawbacks of the Bohr's model. Now let's talk about the drawbacks of the Bohr's model. The first one was that he could not explain the model for multi-electronic systems. I am writing in short form. Do not use it in the examination ever. Bohr's model could be applied, I told you, only for one electron system like H, He plus, Li2 plus, Be 3 plus, and so on. It could not apply to multi-electronic systems. So we wanted something to be generally applied. Then that's a drawback. Second is, there is no justification of angular momentum. He did state no justification for angular momentum. You remember he stated angular momentum should be quantized. So mvr is equal to nh upon 2 pi. That's a postulate. So there was no justification. Kyun diya, kaise diya? But it was correct. That thing was correct, but he could not give a justification, because whenever you are say bringing up a new thing, there will be many questions associated with it. Questions as to why did this happen, how did that happen. If you're not able to answer, that's a drawback. So then another thing is that he could not give a clear picture of the chemical bond. He could not explain the chemical bond. His theory involved both classical physics and the concept of quantization concept. And the fifth one is like, he could explain the spectra of the hydrogen atom, but he could not explain the Zeeman and the Stark effect. Zeeman and the Stark effect could not be explained. Now I'll just tell you what is Zeeman effect and Stark effect. Okay. First of all, Bohr could explain the spectra. Spectra means whatever lines are observed. He could give an explanation कि ये line इस energy पे क्यों, ये line इस energy पे क्यों. He could give an explanation for that. Okay, wherever the line is like, whatever the spectra is coming, he could quantitatively and precisely tell that this spectra, whatever you are getting, is correct. But what was the problem? When you actually introduce your system into the magnetic field, then this spectra, one line gets split into several lines. One line gets split into further more lines. That means one line may split into 2, 3, 4, any number. So what he wanted, what he could not explain was that he could not explain the splitting of the spectral lines in magnetic field, and Stark effect is splitting of the spectral lines in electric field. So he could not account for the splitting of the spectral lines. So let's look at the drawbacks of Bohr's model again. Bohr's model was the first quantum model. It is applicable only to one electron system. Then what was the problem? If it is applicable to one electron system, it is not applicable to multi-electronic system. One drawback comes out. Second drawback, he could explain the spectra of hydrogen atom, but he could not explain the splitting of the spectral lines in magnetic field and Stark electric field. So these effects are known as the Zeeman effect. Zeeman and Stark effect imply that it refers to splitting of the spectral lines in magnetic field, and Stark effect splitting of the spectral lines in electric field. So please remember that these are referring to the splitting of spectral lines, and these two effects could not be explained by Bohr's model. Then Bohr model was a mixture of classical mechanics and quantum mechanics. When you know there's a lot of difference. Classical mechanics means continuous energy levels walking through. Okay, and quantum means jumping from one level to another level. So it was like a mixture of classical and quantum. So that kind of discrepancy was there. Then he could not explain this kind of a chemical bond that exists. When you talk about chemistry, if you're talking about the solution of the atom, you should also be able to explain the interaction of atom with other atoms. So you could not account for the chemical bonds. Okay. So after that, I would just like to come to another concept, which is that of wave nature. De Broglie had given his nature, that is the wave nature, or the wave as well as the particle nature of the electron, and his principle can be summed up in a formula, which is the de Broglie's principle, that is equal to, you have H upon P is equal to H upon mv is equal to your wavelength. De Broglie's principle, I'll just write it down for you. What is it? You have lambda is equal to H upon P, and that is equal to H upon mv. So you can get numericals from this also. Now you have so many relations. I suggest what you do is, on a plain A4 size sheet, jot down all the formulae today itself. Will you do it, all of you all? Jot down all the formulae that you've written down. And you know that the formulae aren't tough. And the rest of it is just qualitative part of understanding what an atom, how an atom is. Now, let me tell you, after the Bohr's model, we came on to the quantum mechanics concept. What was quantum mechanics? Study of microscopic particles. And after Bohr, I straight away talked about Schrödinger, giving a complete quantum model of the atom. Some things that you need to remember about Schrödinger wave equation. Okay, Schrödinger wave equation, I want all of you all to listen. As far as notes are concerned, I think I will pass them on to you if you want it for the Schrödinger wave equation. This is a concept which is not directly applicable for your written subjective examinations, but for the entrance examinations you should know. What is the Schrödinger wave equation? It is like some equation where you have a wave function. Now what is this wave function? Like each one of you, first of all we are talking about quantum model, pure quantum model. Quantum model means I am talking about only microscopic entities. And when you talk about quantum chemistry, you are talking about discrete energy levels. They are not continuous, they are discrete. This thing is clear to everyone? Now when I talk about a wave function, just as each one of you is characterized by your name, each one of you has a name, right? Similarly, each of the microscopic entities are characterized by a wave function. You get that point? Each and every electron, proton, nucleus, atom, whatever, it is characterized by a particular wave function. So you understand, wave function is kind of an identity. Say if I know any one of you, the other day somebody was asking a doubt, if I know Divya, somebody asked a doubt, right? If I know Divya, the moment Divya comes to my mind, I will recall all the properties, whatever I know about her, to me. Similarly, the moment you get to know about the wave function, you get to know about each and every property associated with that particular microscopic entity, electron. We are talking about an electron. So got it? The wave function is designated to each of your microscopic entities, and that wave function is like a storehouse of information. The moment you get to know the wave function, you can find out all the other properties associated. One thing is that. The other thing is, just as each one of you is expected to be well behaved, so is your wave function. The wave function should also be a well behaved wave function. Okay? The wave function which defines your electron should also be well behaved. Now what does this well behaved mean? It means that it should be SCF BND. Just repeat it. It should be SCF BND. Repeat it again. It should be SCF BND. That means it should be single valued. एक ही वैल्यू होनी चाहिए वेव फंक्शन की. It should be single valued. It should be continuous. That means when you talk about a wave function, that wave function should go on in continuation. then it should be like you have a sine function. Sine wave function is like this, so it's like a continuous function. Continuous function, when you plot it, like sine is like this, and then say if you have some function which is like this, this or this is like a discontinuous function, so we don't want this. It should be continuous. It should be finite. It should be finite. It should satisfy the boundary conditions. It should satisfy the boundary conditions. You should know only this. Let me just explain boundary conditions. I am comparing the wave function with you all, but you all are macro, wave function is micro. Just as you all are expected to remain within this room when you are studying, when you are taking up a class, you all are expected to remain in this room. So this is like the boundary set for you. So if I am talking about a wave function of an electron, I am expecting the electron to be there in that atom. So if I am talking about, say, hydrogen, the hydrogen has R going from 0 to infinity. So it should remain in that boundary. Otherwise, what's the point of studying that electron? You getting the point? If there are no students listening to me, what is the point of just speaking up like that? So you have to have some boundary conditions. So it must satisfy the boundary conditions. It should be normalizable. You can just note it down. I'll explain the meaning. And it should be doubly differentiable. Doubly differentiable, so you all understand? One differentiation is d by dx. Doubly differential is d square by dx square. You all know that? That is d square by dx square. Okay, now quickly come back to the wave function concept. What is your Schrodinger wave equation? I'll explain in just one statement. Say if you have any operator, you have an operator operating on a wave function, and you get back the wave function along with some value, then it is known as an eigenvalue equation. Your Schrodinger wave equation is simply H operator psi is equal to E psi. What is your Schrodinger wave equation? H operator psi is equal to E psi. Speak up, otherwise नींद आ जाएगी. इसका एक एग्जाम्पल लेके दिखाती हूँ ऐसी इक्वेशन का, which is like a mathematical equation. What is your wave function? Say if it is e to the, wave function means any function. If my function is e to the power minus 2x, if my function is e to the power minus 2x, and if my operator is d by dx, तो समझ लो ये हमारा ऑपरेटर है d by dx. That's the first differential. And then you have this as the function. So what is the answer? Let's look on to the answer. The answer is you will have minus 2 e to the power of minus 2x. So I am getting my function back. देख रहे हो, एक फंक्शन था उस पे मैंने एक ऑपरेटर लगाया, एक फंक्शन है उस पे मैंने एक ऑपरेटर लगाया. I am getting back the wave function along with a value. This value belongs to this operator. मतलब क्वांटम मैकेनिक्स में मेरा ऑपरेटर है d by dx, और उस d by dx की वैल्यू जो है, मैग्नीट्यूड जो है वो 2 है. ऊपर ऊपर से ही समझना है इसको. Your Schrodinger wave equation is simply H operator psi is equal to E psi. Only that much of it is there in your course. You have a wave function. इस पे हमने जो ऑपरेटर लगाया है that is the Hamiltonian operator. This operator is Hamiltonian operator. Okay, and this value of energy corresponds to this operator. Okay, so you have H operator operating on a wave function. You are getting back the wave function with a value which is the value of the energy of that system. So if you know the wave function and the operator, you can easily find out the value of energy. There are only two things that I would be interested in knowing. If you give me an assignment that you have to move something, what something? Tell me the wave function. Say if it's a table. Now how much energy is required to move the table? So if I know wave function and energy, then the problem is solved. Now let me just come back. We are talking about quantum mechanics right now. Who gave the concept of quantum theory? Quantization? Planck. He faced so much controversy in the scientific world. Okay. Schrodinger wave equation, does it have any derivation? No. It is a postulate. What is it? H operator psi is equal to E psi. What is your Schrodinger wave equation? H operator psi is equal to E psi. What is this psi called? Wave function. This wave function defines your electron. Okay, it should be well behaved. What are the functions of a well behaved wave function? S, C, F, B and D. This is sufficient for you all to know. So it should be well behaved. And then when we solve it, this is the equation that we form. Now this is the energy operator. If it is the energy operator, it will have the kinetic energy operator plus the potential energy operator. This is like what energies do we generally talk about? Kinetic energy and the potential energy. When we solve this, what will we get? We will get some value of the wave function and we will get the energy value. Okay? And apart from that, we get the entire structure of the hydrogen atom. Remember that Schrodinger wave equation can be completely solved for only hydrogen atom and similar systems. So again, there is a drawback or the limitation of Schrodinger wave equation that it can be completely solved for one electron systems, that is hydrogen atom. Remember that it is a postulate, there are no derivations for Schrodinger wave equation, and it talks about a wave function also. And when we solve it for the hydrogen atom, we get the energy which we got from the Bohr's model. The energies are the same. The energy that you got from the Bohr's model, it is the same energy that you got for the hydrogen atom here. But here we got 3 quantum numbers. Till now we were talking about only one orbit, n either 1, 2, 3. But here in this case we are talking about different, yes, we are talking about different energy states, but then here we have say different orbitals. Now the orbits change to orbitals, because if I say that I am drawing a line, the electron has to remain in that line only, but the electron has a tendency to rapidly move. A microscopic entity can never be at rest. Please, that's a thumb rule. A microscopic entity, कोई भी electron जैसे है, it's a microscopic particle, it will never be at rest. It will always keep on moving. Okay, so now when I talk about a microscopic entity like an electron, it will always be moving. Now from here, from the solution of the Schrodinger wave equation for hydrogen atom, I got 3 quantum numbers. What are those 3 quantum numbers? N, L and M. Okay, N, L and M. This N is the principal quantum number. Principal quantum number, remember, it tells you about the energy of the shell. It can take up the values as 1, 2, 3 and so on. Okay, first level, second level, third level. So this is the principal level that is being talked about. Then this L is known as the azimuthal quantum number, which tells you about the angular momentum of your electron in which shell. It is also known as the angular momentum quantum number. And the values that it can take up are going from 0 to n-1. The values that it can take up are from 0 to n-1. We will take up an example also for this. Then we have M as the magnetic quantum number. Remember, whenever we are talking about quantum number, means we are talking about some concept which is segregating, discreting, separating out the energy levels. So that means these many energy levels are more. So these are like kind of the main shell, subshell, sub-subshells, kind of that. So magnetic quantum number can take up the values from minus L to 0 to plus L. Let's take up an example. Now here, if I am talking about the principal quantum number here, the subshells generally, when you have L is equal to 0, it's S shell, S. Okay, S is spherically symmetrical. We'll talk about the shapes also, because these shapes are also obtained from the solution of the Schrodinger wave equation of hydrogen atom. So this is spherically symmetrical. When L is equal to 1, it is P. When L is equal to 2, it is D. Okay, and when L is equal to 3, it is F. That you know. The magnetic quantum numbers, let me just take up an example. Let my N be equal to 2. What are the values that my L will now take? From 0 to N minus 1. So it will be 0 and 1. So that means I am talking about my 2S and I am talking about my 2P. So this is the main shell 2, S and P are the subshells. Now further, when M value in this case, when M goes from minus L to 0 to plus L, for L is equal to 0, it will remain as 0 only. So it will be, that means 2S is only one subshell that you have. For P, it will be minus 1, 0 and plus 1. So here I have 3 more parts of P now. 3 more. That means I have that level 2. I'll just finish this up. I have the level 2. That 2 has S and P. And now when I talk about M, division of those levels also. So now for P, I have my Px, Py and Pz orbitals. Right? And then there is another quantum number S, but remember that the spin quantum number is not obtained from the Schrodinger wave equation. So remember that today we have started talking about the quantum theory that revolves around your Schrodinger wave equation, and that is nothing but H operator psi is equal to E psi. Psi is your wave function which has its own entity for a particular electron, and then you have, out of the solution that you have, you are getting 3 quantum numbers. What are those 3 quantum numbers? N, L and M. Principal quantum number, azimuthal quantum number and magnetic quantum number. So next class we will take up more problems on it. Thank you.
कब से गुड आफ्टरनून बोलने के लिए तरस रहा हूँ, बोल नहीं पा रहा हूँ. So good afternoon.
Good afternoon, sir.
Uh, I welcome once again you all. The topic which I have to start today, you can note down. Uh, Basically, I will be focusing throughout vectors. But before I begin vector, there is a very small concept, but very important one, by the name. So let's discuss this and then we come to vectors. Okay. Incidentally, frame of reference is not an official topic which is in the syllabus, but frame of reference does come into picture when you solve numerical problems, particularly at the JEE level. Many cases actually they do require the deep knowledge of the frame of reference, because you might have to switch from one frame to another. And when you switch one frame to another, sometimes seriously you might observe that certain laws which are taken for granted by you, they start failing. Okay? Maybe Newton's law which you have done, very often you have done Newton's law of motion, F equal to ma, and the definition of the force. Maybe all these definitions might be questioned when you change the frame from one to another. So the knowledge of frame of reference is very important. So let me see how many of you know the meaning of frame of reference. Anybody? Let's be more interactive today. अब तो second time आप हमसे मिल रहे हो. Last time क्या पता डर लग रहा हो कहीं डांट ना दे, कहीं गुस्सा ना कर जाए. तो we are comfortable now. जिसके रिस्पेक्ट में, जिस प्लेस के रिस्पेक्ट में हम मोशन कर रहे हैं. जरूरी है मोशन कर रहे हैं? रेस्ट पे भी हो सकता है. तो कुछ और अच्छा सा डेफिनेशन बताओ. any observation which we carry with reference to any place, okay, that place can be frame of reference. So start giving examples of frame of references. Give examples where you can tell me exactly that observation as well as the frame from where it is observed. Whole example, okay? Don't say bus. Then I will say truck. Then someone say train.
अगर सर कोई पर्सन ट्रेन के अंदर बैठा है और वो ट्रेन मोशन में है, अगर कोई सेकंड पर्सन ग्राउंड पे खड़ा है, अगर वो ट्रेन को देखते हैं और उस पर्सन को देखता है, तो उस ट्रेन के रेफरेंस में जो पर्सन उसके अंदर बैठा है वो मोशन में है. बट अगर जो फर्स्ट पर्सन था उस ट्रेन के अंदर बैठा है वो खुद को देखे ट्रेन के रेफरेंस में, तो वो मोशन में नहीं है, रेस्ट पे है.
ठीक है, आपका मतलब एक पर्सन एक ट्रेन हो गया, और कभी ट्रेन फ्रेम ऑफ रेफरेंस बन सकता है पर्सन के लिए, कभी पर्सन बन सकता है. नटसेल में आप यही कहना चाह रही थी ना? ओके. चलो मैं आपसे पूछता हूँ, मैं आपको ऑब्जर्व कर रहा हूँ, मैं आप सभी को ऑब्जर्व कर रहा हूँ, तो क्या मैं अपने आप को एक फ्रेम मान सकता हूँ? ठीक है, आप सब मुझे ऑब्जर्व कर रहे हो, तो यहाँ तो 21 फ्रेम बैठे हुए हैं, 21 फ्रेम, और हम सबको लगभग 500-600 लोग ऑब्जर्व कर रहे हैं. तो जहाँ जहाँ भी इंडिया में ये क्लास ट्रांसफॉर्म हो रही है, wherever people are watching us, that is all frame, and that frame, all frame which I'm talking about, actually part of a country called India. So they all are the part of one single frame called India. जरूरी इंडिया में फिजिक्स की पढ़ाई हो रही है. So wherever the teaching is going on or people are performing their activities, whether Russia, Finland, Australia, the places which I am counting that lie on Earth. So Earth is a frame. तो Earth ही जरूरी है, Earth ही हो. So that means the whole world is also a frame. Okay, don't you feel that means it is such a general to specific and specific to general phenomena that I think we need not to think too much when we have to go into division of frame into frames and then collectively combining all the frames and resulting into single frame, isn't it? For example, there are so many boats in a river. all the boats are going in different directions. People who are sitting in different boats, naturally they are having different frames with them. Everybody has different observation. Someone who is observing this race sitting right somewhere at the bank of the river, he is having one frame with him. Okay, so understood? So what can we write? What is frame of reference? Any place of reference with respect to which what we do, an observation is recorded. Let's see how many types they could be. Yes. Coordinate geometry just tells us that take origin and then x-axis, y-axis, z-axis. That becomes a frame. With respect to frame, we start defining the coordinates of different points. And then you might have been told that how to change the origin, how to shift the coordinate. Okay, shifting of coordinate पढ़ाया जाएगा आपको. Then the same point coordinates will alter, etc. So, how many types of frame of reference could be? Here we will focus types which are basically related with the physics. Not those types जैसे हम अभी train is frame, boat is frame, not that. ऐसे तो infinite frames हो जाएंगे. ठीक है? So broadly, if I classify the frame of references, keeping in mind that laws of physics are going to be very significant when we go into these frame of references, then only two categories of frame of references would be: inertial and non-inertial. Okay, I hope everybody understands this, inertial and non-inertial. Okay, so let me ask how to actually understand the meaning of inertial frame. इसको शॉर्ट में ऐसे कर लें याद करने के लिए, ठीक है? If and if. So how do we understand the frame is if? What is the meaning of non-inertial frame? Inertial frame. What is the meaning of inertia?
Property by virtue of which an object tends to remain in a state of motion or rest unless and until
So this, if you understand the definition of inertia, including both the inertia of rest as well as inertia of motion, you define the inertial frame. That is the meaning of inertial frame. Any frame which is at, जो आपने कहा अभी, which is at rest, either which motion? That is what said, na? So simple to understand the inertial frame. Any frame which actually has got either at rest position or moving uniformly. So inertial frame can be of two types: frame at rest and other one frame moving with uniform speed. Uniform speed. Fine? Is it okay? वो बात और है कि रेस्ट पे कोई भी चीज़ होती नहीं है, वो तो हमारा एक अजम्पशन होता है, क्योंकि किसी भी चीज़ को रेस्ट पे हम जब कहते हैं तो किसी के रिस्पेक्ट में रेस्ट पे कहते हैं. इस दुनिया में कोई भी चीज़ रेस्ट पे एब्सोल्यूट तरीके से नहीं है. अर्थ इज नॉट एट रेस्ट. तो जब अर्थ ही रेस्ट पे नहीं तो अर्थ के ऊपर फ्रेम्स कैसे रेस्ट पे हो सकते हैं? बट आई थिंक यू ऑल आर एट रेस्ट. मेरे लिए तो आप सब भाग नहीं रहा, कोई दौड़ नहीं रहा है, ठीक है? सो मेरे रिस्पेक्ट में आप सभी रेस्ट पे हो. मैं अगर यहीं रुके रुके सारे भाषण दे दूं तो आई एम एट रेस्ट विद रिस्पेक्ट टू यू, isn't it? What about non-inertial? इसका जस्ट उल्टा क्या बचता है यहां पर जो मैंने छोड़ दिया? मोशन और रेस्ट. बचा क्या? Accelerated motion, non-uniform motion. So any frame which is actually having a non-uniform motion, that would be non-inertial frame. So I can say accelerated frame, accelerated or retarded. Retardation or acceleration frame. Both are same, just a negative of acceleration is retardation. So I'm not saying uniform acceleration. Acceleration, whether it's a uniform or time dependent, doesn't matter. But any frame which is actually moving with some acceleration, those frames are non-inertial frame. Okay. Now can we talk about certain non-inertial frame which is there in our routine life? Non-inertial frame. Give example of non-inertial frame. Which is bound to be non-inertial. Come what may, कुछ भी कर लो, कितनी भी आप जतन कर लो, you can't change that nature of the frame from being non-inertial. Come on. Vehicles. Can any vehicle be inertial? How can? How can? When it moves with uniform velocity. Okay. So is there any vehicle which moves with uniform velocity? या सिर्फ ख्यालों में है, thought में है, सोच रहे हो सिर्फ? Guaranteed है, no vehicle can move uniformly. अगर आज चल रहा है तो कभी तो रोकोगे, और जब कभी रोकोगे तो कभी चलाओगे भी तो सही. Human being also. Lift. Non-inertial, inertial. No lift can move without acceleration and deceleration. मतलब चला दोगे तो चलते ही जाओगे. किसी फ्लोर पे तो रुकोगे. So जितने मोशन के एग्जांपल सब आपके दिमाग में, कोई भी आप ऑब्जेक्ट ले लो, चलो ये तो मैंने दो एग्जांपल दिया. टेक any example which is moving around you. I can guarantee that only for certain time duration we conditionally make that example to be inertial. Otherwise they actually belong to non-inertial. Like escalator. The escalator चाहे mall हो, चाहे railway station हो, I don't think that escalator moves on and on. कभी तो रुकता है. रात में जब कोई नहीं चल रहा तभी चलाते रहेंगे. कभी तो रुकेंगे, और जब तुम स्टॉप करोगे तो इमीडिएटली नहीं रुकता वो. ब्रेक थोड़ा सा कम, तो दैट इज नॉन इनर्शियल. Because these things are man-made, and man himself has got this attribute or the ability or the property by Almighty that man has to be always non-inertial. He has to move and stop and accelerate and retardate. Yes. I don't know. Let's throw this to all your friends. They will decide. Is it, children? She says, what is your name? Divya says that sun is also. Sun is the inertial frame of reference. कौन सा ऑब्जर्वेशन सन पे जाके लोगे? But anyway, अगर कभी ऐसा हुआ तो. Sun is moving uniformly. Sun is at rest. Is it not moving? I doubt. Because I have heard that in galaxy, nothing is at rest. And sun is the part of your galaxy. Out of all infinite stars in your galaxy called Milky Way, sun is one of the stars. And none of the stars can be at rest. If you believe that their origin actually got by virtue of some blast or whatever, then how come they be at rest? They all are moving. And in fact, the whole universe is expanding. Sun is also expanding. But daring to say that sun has got this velocity, I think it's such a big statement. Probably I might have to prove it, which needs certain, tremendous amount of accuracy for an experiment to be performed, particularly from the surface of Earth, to take that small, slightest motion which the sun or any such stars perform. Though they have done, people have done. The redshift, concept of redshift, which you'll be taught in which class? This class only. Maybe when you do the waves at the end of this year, then you'll be given a concept of redshift, Doppler effect. Have you heard Doppler effect? Acha nahi. So the redshift actually is a concept where we prove that experimentally that the stars are moving away from each other as well as from us. Okay, using the Doppler effect. So that's a proof that if the stars are moving, even sun will move. and such natural motion cannot be uniform. पटाखा अगर कभी फोड़ो आप, अब तो आ रहा दिवाली फोड़ोगे ही, ठीक है, क्या पता फोड़ दिया अब तक. तो ये जो टुकड़े होते हैं पटाखे के, all these fragments, they actually start from the place where the bomb is takes blast, and then it moves randomly in all directions with a non-uniform motion. Take a stone and hammer it. All the fragments, you can't take it guarantee that they're going to be uniform. You cannot, in fact, you cannot take a guarantee of any natural phenomena occurring at a uniform space, if it is a natural phenomena. Okay? Even the circular motion, which you sometimes tend to give with example, the earth is moving in a circular motion around sun, even that happens to be a non-uniform motion, because the circular motion actually is a motion where the direction changes continuously, and if the change in direction is associated with any motion, it will definitely have an acceleration. So how can it be uniform? And what is that acceleration called? Centripetal. Okay? Is that okay? Let us now write two important properties which I will be taking care when I will be doing your laws of motion, or somebody whosoever will take that particular topic. And those properties are, you can note down, laws of motions. Newton's laws of motions are not valid here. लिख लो. Newton's laws of motions Newton's laws of motion are not valid in NIF, non-inertial frame, in as it is form. ये भी लिख लो, ऐड कर लो. As it is form जैसे आपको पढ़ाया जाता है न्यूटन्स लॉ ऑफ मोशन, उसी फॉर्म में अगर आप अप्लाई करना चाहोगे तो दैट लॉ इज नॉट वैलिड. We might have to think of another fictitious force or the virtual force called pseudo force in order to make that law applicable in non-inertial frame, ठीक है, which we'll do in laws of motion, ठीक है, pseudo force and all that. Whereas all the laws are valid in if laws are valid and true. I just give you an example. Just see this example, just to make this concept clear. कहाँ निप पे करते हैं? अच्छा, जो हम लोग यहाँ करते हैं, तो उसमें actually you ignore the motion of earth most of the time. तो एक सेंस में तो तुम्हारा सवाल का जवाब है यहाँ गलत है, क्योंकि why do you ignore? Who gave you permission? राज थोड़ी चल रहा है अपने पापा का, जब मर्जी तब कर लिया, जब मर्जी तब नहीं किया. बट फिजिक्स में प्रॉब्लम बताता हूँ क्या है. इफ वी बिकम सो जेनरस एंड सो साइंटिफिक, यू आर ऑल द टाइम इनवाइटिंग ट्रबल फॉर योरसेल्फ. आई एम टेलिंग यू, एंड दैट इज नॉट एन इंटेलिजेंट वे ऑफ स्टडी एनी सब्जेक्ट. कुछ पढ़ना शुरू नहीं किया कि आफत आ गई, ठीक है, तो आप आफत से लड़ोगे या पहले पढ़ाई करोगे. सो वी गो फॉर अजम्पशंस. नोटिस किया होगा आपने, इन फिजिक्स लॉट ऑफ अजम्पशंस आर देयर. इट्स नॉट शौक नहीं है, करें तो क्या करें. There are so much complications which we assume. We cut short those possibilities which will make you in trouble, and then we generate an environment which is obviously not real, virtual, fine, no problem. But we create an environment where the number of questions which you are going to ask, they are limited, and then we always answer you. And then we later on generalize it, and then we say that for JEE level, something like this, for practical, this. We say the threadless mass, massless pulley. A massless thread, massless pulley, how is it possible? But the things which are taught in classes, class 11th, we always take a smooth surface. How is it possible to have a smooth surface? But the laws of motions are taught majority of the periods taken by the teacher in your CBSE classes, that actually goes on with the massless thread, massless pulley, and frictionless surface, a smooth surface. Okay? Is it okay? See one example. There is a table, and there is a mass on this table, and force F is applied on this table. Table is actually moving in this direction. Just see that example. I want to give an example to explain a little bit that how does it fail? Why the law fails? Many of you might have heard this first time, that the Newton's law fails. Okay, तो बहुत बड़ा statement हो गया. So give me one thing. Give me one. Suppose this mass is actually allowed to slide on this surface, on this table. So that means when I move it, if it is allowed to slide on this surface, there is all possibility that even this starts moving on this top, and it might fall down. There is no limit of application of the force. You can go on and on. F can be of any value. F can acquire any value, so don't worry. So when I start moving slowly, gently, बिल्कुल आराम आराम से, this mass might move with this bigger mass together without sliding on the upper mass. But the moment I start moving fast, speeding up, accelerating, there is a possibility that this goes down. Okay, something which you can often do. I mean, keep your water bottle on your head and start running on the corridor of the school, free period or the break. And you can always have a wonderful balance when you are maintaining. But the moment you start running, obviously just fall down. My question is very simple. Why this bottle falls down? Why this mass goes at the back? Where is the force? Who has applied the force? Force is applied on this mass. Honestly, you're not applying any force on this mass. Force has been applied on this mass as far as the knowledge of the center of mass is concerned. Whatever force has been applied, this force is actually acting somewhere here. What makes this second mass, this smaller mass, to move in backward direction? What is your answer? Inertia? Inertia of rest? So inertia of rest makes it move? Because the body has rest, body will always move when you apply some force. Earlier the body was at rest, and from rest if a body is moving, पहले तो समझो मैं जो पूछ रहा हूँ, ठीक है, उसको फिर जो जवाब दोगे वो थोड़ा relevant होगा. Body was at rest in the beginning, and suddenly it started moving. How can it move without applying any force? But from where that force gets generated?
Due to inertia of rest, the body which is kept above has a tendency to be in rest. But when the force is applied, the table or the substance on which it is kept, it moves forward and the body falls down because of that.
Look, don't get lost into this term inertia. Vibration, please. Don't get lost in this term inertia, because inertia is a property. Inertia is the property by virtue of which you say blah 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 remains at rest and blah 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 comes in motion. But don't forget that a body at rest might be at rest because it is actually being acted upon n number of balance forces. इस आप ये कह के निकल नहीं सकते, पल्ला नहीं झाड़ सकते कि इनर्शिया की वजह से. एक दूसरा सवाल भी हो सकता है, ये इनर्शिया क्या है, रेस्ट पे कहां से हो गया, तो क्या कहोगे, प्रॉपर्टी है. मैं बोल रही हूं ना, प्रॉपर्टी है बस. तो ऐसे तो प्रॉपर्टी पे खत्म तो हम हर चीज को कर सकते हैं. कोई भी चीज जहां टफ लगे प्रॉपर्टी है, बोले प्रॉपर्टी यार मानो मानो दजित मत मानो. तो बॉडी इज नॉट मूविंग. इनर्शिया जब कहते हो कि बॉडी एट रेस्ट विल रिमेन एट रेस्ट, ये भी तो बोलते हो फर्स्ट लॉ में. अब बॉडी इसीलिए बोलते हो क्योंकि पता है आपको कि अगर उसके रेस्ट पोजीशन को डिस्टर्ब करना है तो यू नीड अ, तो आप बोलते हो एज लॉन्ग एज, तो एंड इफ अप्लाइड देन द बॉडी विल नॉट बी एट रेस्ट. सो वही तो मैं आपसे सवाल कर रहा हूं. द बॉडी इज नो मोर एट रेस्ट. दैट मीन्स समबडी हैज अप्लाइड सम एक्सटर्नल, फ्रॉम वेयर दैट हैज गॉट जनरेटेड. कहां से आया वो फोर्स? इस ये मूव करेगा, इस पे तो जवाब है. अब कहां से आया इस पे फोर्स? हमने लगाया एक्सटर्नली. इस पे फोर्स कहां से आया? ओके, अब फ्रेम ले आते हैं. फ्रेम, सपोज मैं इसे पूरे ऑब्जर्वेशन, पूरे इवेंट को एक बार यहां से ऑब्जर्व कर रहा हूं, एक बार यहां से ऑब्जर्व कर रहा हूं. ठीक है, आई एम ऑब्जर्विंग द होल इवेंट फ्रॉम टू डिफरेंट प्लेसेस. विल द ऑब्जर्वेशन बी सेम? चलो बताओ, what A will observe and what B will observe. चलो इसके लिए बताओ, इसके लिए what B will observe, this is moving, इसको भूल जाओ थोड़ी देर के लिए. B is moving, what A will observe? B is not moving. B is not moving, B is at rest. Okay, this is moving with some acceleration, yes or no? Because some force has been applied which is unbalanced, and every time you apply unbalanced force on a body will move with some acceleration, Newton's second law of motion. So these two observations, there are two different observations. If I say, this says that this body is not moving, okay, that means I am in totally contradicting the observation of. झगड़ा हो जाएगा अगर फोन दे दूं ना दोनों को, बहुत तगड़ा लड़ाई होने वाली है. ये कहेगा है झूठ बोल रहा है, कहेगा नहीं मुझे आके देख, यहां से आके देख, नहीं चल रहा है, अरे तो मुझे चल रहा है, क्योंकि दोनों के प्लेसेस अलग अलग हैं एक्चुअली. तो अब लॉज के हिसाब से सोचे, अगर इसके लिए न्यूटन्स लॉ क्या कहेगा? F इक्वल टू ma. इसके लिए न्यूटन्स लॉ कहेगा F इज नॉट देयर, क्योंकि बॉडी मूव नहीं कर रही है. ऑब्जेक्ट सेम है, ऑब्जेक्ट नहीं बदला, ऑब्जर्वर बदल गया. And because of the change in observing places, you are having two different conclusions. The same body, if I say at rest, and accepting that actually some force is acting, I am contradicting myself. So don't you say the law is failing? Newton's law is failing. And which kind of frame is this? Is it inertial or non-inertial? Because this is accelerating. ना अभी भी काम चल. अब इसकी अगर मैं बात करूं, यहां तो ठीक है, यहां तो फिर भी बहुत ज्यादा डिस्प्यूट नहीं होने वाला, क्योंकि ये बड़ा सिंपल है, इनको एक्सचेंज करा के विश्वास दिला सकते हो. अगर मैं इसके मोशन की बात करूं तो इट इज एक्चुअली मूविंग विद रिस्पेक्ट टू दिस एज वेल एज विद रिस्पेक्ट टू दिस, बट इसके रिस्पेक्ट में इसका जो मोशन होगा डिफरेंट होगा, क्योंकि ये इसके ऊपर चल रहा है. इसका तो ये जो ऑब्जर्व करेगा इसका आगे बढ़ना, वो क्या होगा, इसका इधर जाना माइनस इसका इधर जाना, वो इसे ऑब्जर्व होगा, क्योंकि ये भी तो इधर गया. तो ये नीचे वाला इधर गया, अगर x और ऊपर वाला x1 गया, तो नीचे जो बैठ के ऑब्जर्व कर रहा है, ही विल से दैट इन टोटलिटी ऊपर वाला कितना गया, x माइनस x1. डिस्प्लेसमेंट बदल गया नीचे वाले के लिए. ऊपर वाला क्या कहेगा, हाउ मच इज डिस्प्लेसमेंट, x1 ओनली, क्योंकि x तो वो ऑब्जर्व कर ही नहीं सकता. क्यों? क्योंकि उसी का पार्ट है वो. ठीक है, तो जैसे हम लोग अर्थ के इफेक्ट को इसीलिए छोड़ देते हैं कि हम उसके पार्ट हैं, तो ऑब्वियसली जितना अर्थ चल रहा है उतना हम चल रहे हैं. तो विद रिस्पेक्ट टू अर्थ एक्चुअली वी आर इनर्शियल विद रिस्पेक्ट टू अर्थ. सो डिस्प्लेसमेंट इज चेंज. Consequently, when I start to apply the equations of motion, s is equal to ut plus half at square, same s cannot be taken. For them maybe both of them initial velocity could be 0, क्योंकि starting from rest, s you cannot take same. How can you take a same? Time will be same because events are occurring simultaneously. So a has to be different. Don't you feel so? I'm simply saying equations of motion जो आपने derive किया है kinematics में, s equal to ut plus half at square. S displacement observed same, u being same, displacement are different, u being same, time being same, a has to be different. Go back now. How to find a? Force upon mass. So the force has to be same. That means maybe the net force acting over here is different than the net force acting over here. So maybe I'm going to require some force over here, which is hidden, which is not visible to all of you, which is not practically visible, but maybe it is acting. And now if I question again you that what makes this body move over here, maybe some force is getting originated. maybe that force is not originated by virtue of a physically applied by some external agency, but originated by its own. अपने आप ही get originated. Since there are so many hidden things, so there is nothing wrong to call such force as pseudo force, because pseudo means छुपा हुआ. So such force we call as pseudo forces, which get generated in a frame which is non inertial. और उस फोर्स के साथ अगर मैं सॉल्व करूं अभी क्वेश्चन तो आराम से सॉल्व हो जाएगा. इफ आई टेक दैट फोर्स हियर से एफ एस pseudo force and then maybe friction Fr over here, I can always write net force as F minus Fr, which is equal to mass into acceleration. Obviously this force is different than this. This is Fs. And then displacement will also, A different होगा, displacement भी different होगा. So I will reach to the conclusion. Fine. All these things, don't try to start wondering, क्योंकि ये आज का topic नहीं था. ये I was just telling you कि how do we actually treat the non-inertial frame in limelight with the force called pseudo force. We have to do it when we do later on laws of motion. Fine. In inertial frame, we need not to have such kind of forces. So this is again going to be done. Pseudo force will be again taught to you. So very much in the syllabus of IIT JEE. Maybe in your board syllabus, it might have not been taught. Simply ऐसे cases कराए गए होंगे जिसमें Newton's law apply होता होगा. ठीक है? Let's begin another topic today. Vectors. As I told you, there are certain mathematics which we require in doing physics. And this is one of them. It is maths, but actually it is very much required to do physics, vectors. So basics of vectors should be very much clear to all of you. Okay, I hope that as far as the definition is concerned, we all know how to define. Let me check. What is the definition of vector? Any quantity having direction, that is vector. So let's take an example. Electric current move from high potential to low potential. So it has magnitude as well as. So is it a vector? Answer is no. So the definition is wrong. ठीक है? Anyway, आप इससे नहीं, ज़्यादातर लोगों से ये गलती हो जाती है क्योंकि we just stop it here, saying that any quantity having both magnitude as well as direction is known as vector. So थोड़ा सा और समझते हैं. किसी को vector कहना ये sufficient नहीं है कि उसके पास डायरेक्शन और मैग्नीट्यूड हो, you will say the vector. ये एग्जांपल एटलीस्ट ये सिखा रहा है. एक और एग्जांपल देता हूँ. Heat flows from higher temperature to, so it has both magnitude as well as. So is it a vector? Right since your birthday till today, time is moving in one direction. Same for me, same for sir, same for ma'am, same for everybody. So time has a magnitude as well as a direction. At least we have not seen time going back. Maybe the Hollywood movies might, give us movies where the time travel and all those things are displayed. But at least I have not seen anything going back in time. So time has a magnitude as well as. So is it a vector? No. So anything having magnitude, and every shining object is not gold, you might have heard it. So anything having magnitude as well as direction may not be vector. So what is this cross product? When you want to define, at least make the definition simple, because then we have to define cross product also. अब पता नहीं cross product क्या होता है. हमें पता है आपको आता होगा, but definition, at least definition में the dot product, cross product ना ले आए. So we can have very simple way to understand. If there are certain other simple laws other than this cross, then let the vector be defined in view of these laws being obeyed by vectors, apart from having both magnitude as well as direction. And one of the simple law which every vector must obey is the law of addition. Law of subtraction is the part of law of addition only. So if anything has to be a vector, you can note down, a vector is a quantity having both magnitude and direction and obeying law of addition. If it doesn't obey the law of addition, it is not vector. Current doesn't obey the law of addition. Two forces acting in this diagram. What is the resultant? Tell me. Okay. So in which direction the body will move? In none of the direction. Two wire carrying current 3 ampere each. What is the current in this wire? Interesting. So how can they be vector? अभी और यही नहीं. If I tilt these two wire, what is the answer? What is this result? I'm tilting. Say 120 degree. What is the answer of this current? 6 ampere. Say 30 degree, 6 ampere. 60 degree. For vectors, it doesn't happen. For vectors, the angle plays a significant role. So ये तो तय है कि current is a pseudo vector. Why to call pseudo vector? Again, it looks like a vector, but actually it is not. Such pseudo vectors are called tensors. What? Tensors. You can write somewhere. Pseudo vectors are tensors. What is the meaning of pseudo vector? A quantity which look like vector, but actually it fails to obey the law. ठीक है? So current is a tensor. Electric current is a tensor. Definition clear हो गया वेक्टर का? Fine. अब अगर हमें वेक्टर दिखाना हुआ तो वेक्टर दिखाएं कैसे? एरो लगा के. ठीक है? तो एरो कैसे लगाएं? ऐसे. इसका मतलब क्या हुआ? What is the meaning of this and what is the meaning of this? So this is a vector and this is the mod of the vector, magnitude of the vector. So numerical value only. What is the meaning of this? If I say this is a vector, what is the direction of this vector? मैंने arrow right लगाया है. So can I say that the direction is also towards right? तो right क्यों लगाया arrow फिर? Then why have we put the arrow right? It's a sign only. I think I wanted to hear that. So actually this right has nothing to do with the actual direction of the vector. It is just the way you represent. Okay? Otherwise there will be very funny if this vector has to be represented, somebody might represent like this. Okay? So just to give everybody the same way of writing, the direction is always represented from left to right, whether the vector is right to left or left to right, up to down, down to up, or any direction. Fine? Is it okay? इतना clear है? एक और basic जहाँ आप लोग अटकते हो उसको बताओ, उसके बाद then आपका syllabus शुरू करता हूँ. Many of us actually fail to draw two vectors if the angle between the two vectors have been given. You do very often mistakes. If I say that represent in your copy two vectors inclined at 60 degree. Draw करके दिखाओ. Just draw two vectors which are inclined at 60 degree. कोई भी दो वेक्टर बनाओ जो 60 degree पे inclined. And show me. Show me that. Just show me. Anybody? Very good. Correct. Correct. It's all intelligent children. आप दिखाओ. Very good. ये तो टेबल पूरा सही है. अभी ये बना रहे हैं. आपने ये सोच रहे हैं. आप wrong. देखो एक विकेट गिर गया, रॉन्ग, 2 विकेट गिरा, 3 विकेट गिरा, अरे तो सारे ऑल आउट हो जाएंगे, राइट। ये या ये, जल्दी बताओ, ये या ये सच बताओ, ये या ये, रॉन्ग, विकेट गिर गया, लास्ट में गिर गया, राइट, एरो, अरे हाँ विकेट गिरा, गरा इनका भी विकेट गिरा, गलत। चलो एनीवे मुझे मतलब इस बात से है कि देखो यहाँ भी बैठे एटलीस्ट 10-12 बच्चों को मैंने चेक किया, उसमें से 6-7 तो गलत बना रखे। क्या इतना टफ है ये? हाँ वो ठीक है, दूर से, मेरा चश्मा कहाँ यार, मुझे दूर की प्रॉब्लम है, मैं चश्मा मंगवा देंगे क्या, वहाँ 5th फ्लोर पे छूट गया है। हाँ जरा टेक्नोलॉजी का इस्तेमाल करिए। हाँ ठीक है, हाँ ठीक है। ओके, सो दिस इज द राइट वे, दिस इज द राइट वे एंड दिस इज द रॉन्ग वे। दिस इज द रॉन्ग वे, दिस इज रॉन्ग, दिस इज राइट। अब लॉजिक एक क्या हो सकता है रॉन्ग राइट का, देखो कितना फनी लॉजिक, कितना सही लॉजिक है, लेकिन ये इसलिए रॉन्ग है क्योंकि ये राइट है। अब कोई दबंग अगर होगा तो कहेगा है हेलो हमारा सुनो, ये इसलिए रॉन्ग है क्योंकि ये राइट है। तो सब अपने अपना खिचड़ी पकाए यार, कोई कंसेप्ट ही नहीं है इसका, मतलब तो कंसेप्ट समझते हैं, ठीक है, ताकि आप भूलो ना बाद में कभी, ऐसी और सिचुएशन डिफिकल्ट हो सकती है। एक्चुअली व्हेन वी आर रिप्रेजेंटिंग द वेक्टर्स, वी आर एक्चुअली ट्राइंग टू रिप्रेजेंट 2 क्वांटिटीज विद रिस्पेक्ट टू देयर डायरेक्शन एज वेल एज मैग्नीट्यूड। ये तो क्लियर है? So don't you feel that this is the actual direction between the two, whereas this is the direction which you're talking about is between this and this? Direction के sense में सोचना, you're not talking about this angle, is actually not talking about these two, this direction actually is this and this direction is this, so what is the angle? तो गलती हो गई। So एक चीज निकल कर आई, कंसेप्ट जो भूलोगे नहीं कभी, इसको ध्यान से देखना और इसे देखना, ये दोनों वेक्टर्स के टेल यहां ज्वाइंट है, ठीक है, और इनको पीछे बढ़ा दूं अगर मैं, इसको भी ऐसे कर दूं तो हेड भी ज्वाइन हो गए, तब भी 60 होगा। इसका मतलब जब हेड हेड या टेल टेल ज्वाइन हो तब तो एंगल राइट होगा, और जब भी कभी हेड टेल ज्वाइन हो तो भूल के भी एंगल मत लेना, कोशिश क्या करना, किसी तरीके से उसे हेड हेड या टेल टेल में कन्वर्ट कर देना, उसके बाद एंगल सोचना, ठीक है। हो सकता है डायग्राम आपको कंफ्यूज करने के लिए दिया हो, सो नोट कर लो कहीं पर, एंगल बिटवीन 2 वेक्टर इज ऑलवेज, एंगल बिटवीन 2 वेक्टर इज ऑलवेज considered by joining the vectors head head or tail tail, head to head or tail to tail, is always considered by joining the 2 vectors head to head or tail to tail. So what is the angle between these 2 vectors? What is the angle between these 2 vectors? 150 degree, very true. ठीक है, is it okay? Another basic mistakes which I see children doing, mostly children I have seen writing this. Even if I rub this, what do you read this? So why do you write vector A? Okay, so never write vector in front of a vector, because as it is you are going to read it vector. So these were certain basics which are not in the book, but then I thought that I must tell you. Let us now begin with it. Types of vectors. How many types of vectors could be there? Only 2? Only 2 types? Have you heard about unit vector? How to represent? By putting cap. And the magnitude of this unit vector is always going to be, how to define unit vector? Vector upon its, fine. The three popular unit vectors are popular because we actually do lot of exercise with using them, and they are at 90 degrees. Incidentally, they also form a set of vector which is another category called orthogonal vectors. What is the meaning of orthogonal vectors? Theta equal to 90 degree. So when two vectors are inclined at 90 degree, we can call them orthogonal. Should I rub? ये तो मिटा सकता हूँ ना? Then parallel vectors. Any two vectors having theta equal to 0 degree. Then coplanar vectors. Can you give examples, children? Can you give examples of coplanar vectors? Have you engaged yourself in the billiard play or the carom board play? So I guess that the board which you are using is a flat board, plain one. ठीक है, curve तो नहीं होता होगा. So all the strikers, when you strike, they actually move in different direction, all right, but they actually represent velocity which happens to be in the same plane. So I can say they are coplanar. ठीक है? Any other? Negative vector is opposite of the positive vector. Any other type of vector? Position vector. Position. रुको पहले position समझ लें. What is position vector? A vector which represents the position of a point. So if I have to represent position vector, say this point is say x1, y1, z1. So this OA is a position vector. Join the vector from the origin to the point whose position you have to represent, that is going to be position vector. Null vector. Null vector. It's a very funny vector because I wonder that how somebody can represent this. Definition says that any vector having zero magnitude. So how can this vector be represented? I fear that anybody can represent on the board or on the copy, because you are not allowed to draw any line of any magnitude, because the moment you draw a line that will have some magnitude, so it's no more zero. So how to represent it? It's not possible. Practically not possible to represent. Then maybe we are actually defining it for taking ourselves out of a crisis somewhere. Somewhere maybe in physics we might stuck to a situation where we feel that there is a crisis, and then we will define such vector which actually we need not to draw on the paper. But we have to just define it just to come out of that crisis. And it's very simple to understand. What is the result of addition of two vectors? If I add two vectors, what is the result? Vector. If I subtract two vectors, result is vector. Force minus force and force plus force. So what if you add two equal vectors? Double of the single one. What if you subtract two equal vectors? So you have to say the zero vector. Zero is all right, fine. But it has to be vector, because अभी थोड़ी देर पहले आपने कहा subtraction of two vector has to be a vector, so call it vector. Forget about that headache of representing it. Who wants to represent such vector? Even I don't want. ठीक है, तो लिख लो कहीं पर null vector actually is defined, null vector is defined null vector is defined where two equal vectors are subtracted. What is the result of cross product of two vector? थोड़ी देर पहले आप लोग बोल रहे थे. What is A cross B? ब्ला 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 ब्ला. ओके, मैंने भी बताया नहीं, इसलिए जो आप बोल रहे हो सब सही है. A B whatever. So if I say A cross A, then is it? No, it is 0. A cross A is 0. But the cross product of two vector has to be a vector, because the definition of dot and cross product is dot product is actually result into a scalar and cross product results into a vector. So where is that vector? 0 vector. So null vector we need here also. Okay, I have provided you two situations where we define such funny vector. Okay, yes, we define it, but I'm sorry, as far as representing on the paper is concerned, we all are having the same problem. So we don't represent them because we are unable to represent them. ठीक है, is that okay? Now let's do vector analysis. Let's try to understand different vector operations. How do you operate with vectors? Can you think of two vectors which are equal? Can you tell me that when you can say two vectors are equal? If I say vector A is equal to vector B, what is the meaning of this? Both magnitude as well as direction are identical. Fine. Is it okay? Let's multiply a scalar with a vector. So multiplication of a scalar with a vector. Say vector A is n times vector B. This was vector A. Tell me vector B को कैसे represent करें? Where n is a scalar. N is a scalar. It can be a number. It can be an integer. It can be positive. It can be negative. It can be in fraction. Okay? Then the everything which I am talking about is going to be decided by n. So this scalar takes the whole case hijack. It is the value of this n which will now determine the value of A, except one property which cannot be hijacked. Direction. Only two possibility. Either the direction which B is having or opposite of that. So this property cannot be hijacked. Rest everything could be possible. Smaller, bigger, whatever. Okay? If it is minus, then direction of A will be opposite of direction of B. ठीक है? वो तो opposite हो जाएगा ना? So कहीं लिख लो direction will remain same if n is positive and will be opposite if n is negative. Or what about magnitude? Magnitude of A depends upon the value of n. Let's add two vectors now. I want to add these two vectors. The angle between them is given theta. Before I coming to the laws, the triangular law, parallelogram law, which you are very much aware of, we are not doing these things, अब तक जो मैंने पढ़ा है, we are not doing these things which we don't require in physics. Every time we are doing anything here in vector, we actually require them in physics. So could you tell me where do we require in physics addition of two vectors? Examples. Where actually we need a case where we want to add two vectors. Give me examples out of physics. Still don't make me roam around something. Give me specific example. वही तो मैं चाहता हूँ. इतने बड़े हो गए हो, इतने सारे examples आपके पास हैं. You perform so many activities in your day-to-day life. Okay, rain falling and you are having umbrella and moving or running with some velocity. So there you need to add which two vectors? Velocity of the raindrop. And why do you need to add? To save yourself from rain. Okay. Actually, frankly speaking, there we might not need addition, we might need subtraction or whatever addition, subtractions. But I think it's a good example. We might have to bother about the resultant of one vector and another vector, because maybe the result which we are going to observe is going to be not a single vector effect, it's an effect of both the vectors. Okay, so that is a practical example. Another good example I can say, my father always walk in the morning and he starts walking from one point and he actually come back to the same point naturally. घर से start करके घर वापस आ जाते हैं. इतनी बड़ी बात बोल गए. ठीक है. So now when he move, actually he moved from one place to another and then he turns from that place to in other direction. Obviously he has to come back and then he has to turn again and take another path, then turn again, take another path. At this process, if at any point of time I have to stop him and I have to tell him that from the initial point from where he started, where actually he is lying, I need to know how to add vectors, because I won't be able to tell otherwise. I might have to tell direction as well as the magnitude. So you know the displacement? How to define displacement? What is the difference between distance and displacement? Shortest distance between 2 points. So this is always obtained by vector addition. Because how do you obtain? These 2 points are added by two vectors. Now tell me the displacement. Shortest distance between 2 points. यही तो हुआ. So it's a displacement. And this displacement is nothing but a vector plus v vector. And it could be so many vectors together, and still if I ask that what is the displacement with a vector plus b vector plus c vector plus d vector plus e vector plus f vector, it's all r vector. That means the displacement हम लोग पढ़ते हैं kinematics में, actually that comes out of addition, knowledge of addition of vectors only, nothing else. क्योंकि आप ऐड ही तो कर रहे हो, but you are adding them vectorially. You have to be careful. You are adding them vectorially. That means you have to take care magnitude as well as direction, and that is why some of these two, maybe this is 5 meter, this is 5 meter, but I am afraid that this will be 10 meter. This is not 10 meter. Because actually they are being added at angle theta. So the result will always not be 10 meter. There will be a case, one case, unique case, when the result of 5 meter and 5 meter will be 10 meter, and that is when the both vectors are directed in the same direction. Rest of the cases not 10 meter. इसका तो हम लोगों को कुछ फॉर्मूला वगैरह हो सकता है सीखना पड़े. Let us now come to the law, क्योंकि law हम बनाते इसलिए हैं ताकि उस लॉ के रिजल्ट पे जो फॉर्मूला निकले उस फॉर्मूले को आप अप्लाई करके डायरेक्ट रिजल्ट निकाल सको. तो देयर आर टू लॉज. द फर्स्ट लॉ इज triangular law. What is triangular law? So what is triangular law? When you join two vectors such that the head of first vector is joined with the tail of second vector, then the resultant of the two is actually obtained by joining the tail of first vector with the head of second vector. एग्जाम में लिखना होता है इसलिए बता रहा हूँ, यहाँ मत लिखो, यहाँ तो आपको पता होगा. So when you actually represent vectors like this, at the end of the day the resultant is actually joining the tail of first vector with the head of second vector, and this resultant will be in magnitude using simple Pythagoras theorem. It would be b sin theta. If I resolve, this will be b cos theta. So I can simply apply Pythagoras theorem and find this is 90 degree. The resultant magnitude would be a square plus, इसका derivation देने की जरूरत नहीं है. If this angle is alpha, using trigonometry, you can write tan alpha. Tell me how much? Perpendicular upon base. So how much it comes out? B sin alpha upon. Sorry. So using first formula we can find the resultant. Using second formula we can find the direction of the resultant. Okay. What is this direction representing? It is representing the direction of the resultant with respect to which vector? A vector. ठीक है? If I ask you tan beta, then it becomes with respect to B vector. Who will tell me tan beta in the diagram? बोलो. ऐसे अटक जाते हो छोटी छोटी चीजों में. किसके किसके दिमाग में ये है b sin theta upon a plus b cos theta? Raise your hands. नहीं, गलत है. a sin theta कोई बोला, a sin theta दिस इज वेरी राइट. तो इसने किया, आपने किया क्या? आप तो बड़े स्मार्ट हो, ए और बी को इंटरचेंज कर दिया सिर्फ. और करती भी क्यों नहीं? क्योंकि हमने क्या किया, हमने भी तो वही किया. हमने एक पहली बारी हमने आपसे कहा कि अल्फा इज द एंगल मेड बाय द रिजल्टेंट विद ए. दूसरी बारी मैं कह रहा हूं बीटा इज द एंगल मेड बाय द रिजल्टेंट विद. तो कर दो इंटरचेंज. वही तो किया, वही करना है, वही सिखाना था मुझे आपको. ठीक है. सो इस चक्कर में मत रहना कि एंगल जो रिजल्टेंट है वो एक ही है. दो ऑप्शंस हो सकते हैं, दोनों ऑप्शंस को थोड़ा ध्यान से देख के करना. ठीक है, कि किसके साथ रिजल्टेंट एंगल बना रहा है. फाइन. सो दैट आप फॉर्मूला अप्लाई करते समय, क्योंकि यहां बी और ए के टर्म में फॉर्मूला याद कर रहे हो सकता है न्यूमेरिकल करते समय बी और ए ना हो, न्यूमेरिकल वैल्यू हो, तो कोई दो फोर्स होगा, एक 30 न्यूटन एक 20 न्यूटन. पता लगा दोनों फोर्सेस को आपने अलग तरीके से रख दिया, जहां ए रखना था वहां बी रख दिया, जहां बी है तो आंसर गलत आ जाएगा. ठीक है. इज इट ओके? जैसे एक एग्जांपल करके देखें, देखे तो ट्राई करो. फाइंड द रिजल्टेंट ऑफ two vectors. Find the resultant of two vectors acting an object, and the vectors are 20 Newton and 10 Newton. 20 Newton and 10 Newton, and they are acting at 60 degree. Find the resultant of the two vectors. They are 20 Newton and 10 Newton, and they are acting at 60 degree. How to find the resultant? That is the magnitude. I'm more interested in the direction. बट 15 आया कैसे? अच्छा आ गया होगा, कोई बात नहीं. आपने a स्क्वायर प्लस b स्क्वायर प्लस 2ab cos थीटा लगाया होगा ना. Just a minute, there is an online question. Explain the significance of null vector. The null vector has only one significance, that we use this vector. Camera में आ जाता हूँ. We use this vector to define cases where we want to find the difference of two vectors, or maybe cross product of two vectors, where the resultant is actually zero vector. Otherwise, since it's a zero vector, there is no doubt that we cannot represent it, and consequently we call it null. Null means nothing. It's null vector. That is only significance. Sorry? Why not? It will follow the triangular law. $20 Newton, 10 Newton, 60 degree. रिजल्टेंट हो तो गया. ट्रायंगल तो आप बनाना होगा ना. दिखाते समय तो डायरेक्शन में ऐसे ही दिखाऊंगा, ट्रायंगल तो आप बनाओगे. ठीक है. सो व्हाट इज r 20 square plus 10 square plus 2 into 10 into 20. What is cos 60? तो वो तो सबसे पहले किसी ने बताया था 15. जिसने बताया था वो गलत है. तो ये तो 700 आ रहा है. 10 रूट 7. ठीक है. रूट 7 इज 2.64. So it becomes 264 Newton roughly. Sorry, 26.4 Newton. कहीं पर लिख लो, काम आएगा आपके. वैसे जो आता है मत लिखना, जो नहीं आता वही लिखना. ये मत लिखो, ये टफ है. ये भी छोड़ दो, बहुत टफ है ये. ये भी टफ है. ये आपको ना जरूरत पड़ेगी बार बार लॉग टेबल. आई सपोज लॉग टेबल आना चाहिए, लेकिन ऐसी भी क्या लॉग टेबल के प्रति इतनी यारी है कि हरदम लॉग टेबल ही देखते रहेंगे. ठीक है. सो यू जस्ट लर्न इट सो दैट यू कैन यूज देम. ठीक है. द पॉइंट विच आई वांटेड टू मेक, दिस इज अल्फा एक्चुअली. व्हाट इज 10 अल्फा? डायरेक्शन टेल मी. 10 अल्फा. सो 10 अल्फा के लिए मुझे क्या लिखना चाहिए? b sin थीटा. सो व्हाट इज b हियर? ठीक है. 10 sin 60 डिवाइडेड बाय 20 प्लस 10 cos 60. फाइन. 10 sin 60 is 5 root 3 and 20 plus 10 cos 60 is 5. So this is 25. 5 upon 25. So root 3 by 5. क्या करूं मैं इसके बाद? इसको ऐसे छोड़ दूं या ऐसे कर दूं? tan इनवर्स रूट 3 by 5. ठीक है. फिलहाल तो करते रहो, but I think sooner or later you need to know that how to find the exact value in degree, which you will be able to know by log table. So definitely I will give you one class for log table. सिखाऊंगा. ठीक है. ये जो आया, इसका एक काउंटर रिजल्ट भी हो सकता है. अगर ये निकालना होता तो कैसे निकालते? ये बीटा निकालो. If you have to find beta, then tell me tan beta will be, now what is b? Right now it's 20. Therefore, this is 20 sine 60 upon 10 plus
20 cos 60.
that is 10 root 3 divided by 15. So 2 root 3. So this is 2 by root 3. ठीक है रूट 3 बाई 2 या 2 बाई रूट 3 मेरा सही है कैसे cos 60 ये कितना होगा ये 10 होगा अच्छा 10 तो 20 हो जाएगा हाँ ठीक है तो गलत है 20 तो रूट 3 बाई 2 सही है बच्चे सही हैं इसलिए हमने सही कर दिया अपने आप को ठीक है सो दिस इज रूट 3 बाई 2 फाइन इज इट ओके मैं आपको बताता हूं कि पैरेललोग्राम है तो बिल्कुल वैसा ही जैसा ट्रायंगुलर लॉ है but there are a lot of merit in parallelogram law. So see parallelogram law of vector addition. Is it okay? Symbol is fine. You know this symbol parallelogram. So parallelogram law. How to state the law? वहाँ मैंने कहा था head and tail join करना यहाँ you have to join tail to tail and construct a parallelogram law. अगर आपको याद हो मैथ्स टीचर ने पढ़ाया था बेसिक मैथ्स की पैरेललोग्राम बनाने के लिए दो इंफॉर्मेशन चाहिए होती है ऑब्वियसली द एंगल बिटवीन टू साइड्स एंड द टू साइड्स ठीक है रेस्ट यू कैन ऑलवेज ड्रॉ सो दैट इज ऑलवेज गिवन इन दिस केस क्योंकि दो वेक्टर जो ऐड करना हो तो दिया ही होगा और ऐसा कैसे हो सकता है दोनों के बीच एंगल ना दिया हो ऐड कैसे करोगे तो बोथ द इंफॉर्मेशंस आर फर्निश्ड हियर सो आई कैन ड्रॉ द पैरेललोग्राम दिस इज ए दिस इज बी एंड as per the rule what is the resultant is the diagonal which contains the two vectors what is the meaning of containing the two vector if this there are two diagonals any parallelogram will have how many diagonals two diagonals so the diagonal which contains the two vector का मतलब ये हुआ ठीक है ये दो vectors हैं ये जो diagonal होगा that contains the two vector one on the left and one on the right so that diagonal is known as the resultant fine now this is alpha this will be theta so resultant will remain same a square plus b square plus 2ab cos theta and tan alpha will be also same b sin theta upon a plus b cos theta. So what is changed here? Result same. Only diagram had changed. The diagram actually rather than triangle, it's a parallelogram. But somebody says that नहीं sir ये भी triangle है. Actually ये एक नहीं दो triangle है. Okay? ध्यान से देखो. अगर मैं ऊपर वाले triangle की बात करूं, so it's telling me b plus a equal to r. नीचे वाले ट्रायंगल से क्या मिल रहा है एंड दिस एक्चुअली विच जस्ट नाउ यू हैव स्पोकन इज नोन एज द कम्यूटेटिव लॉ सो आई हैव वन इंपॉर्टेंट मेरिट ऑफ पैरेललोग्राम लॉ ओवर ट्रायंगुलर लॉ एंड व्हाट इज दैट डायरेक्टली यूजिंग द पैरेललोग्राम लॉ वन कैन वेरीफाई दैट वेक्टर एडिशन हैपेंस टू बी कम्यूटेटिव ठीक है नोट करते चलो नोट मेरिट्स ऑफ पैरेललोग्राम लॉ ओवर ट्रायंगुलर लॉ merits of parallelogram law over triangular law a plus b is b plus a it is same why do I say same see same diagonal I am representing once from the lower triangle a plus b, and next from the upper triangle b plus c. So obviously sum has to be same. ठीक है? So this is actually which law? Law of commutative. Now I just draw another diagonal just to see that ये क्या represent कर रहा है. Just see this diagonal. Call this as r dash. This diagonal. Just check this triangle and apply the triangular law and tell me how are they related. ये वाली triangle देखो. So which one is sum of the other two? किसी भी ट्रायंगल में दो वेक्टर जो कंटिन्यूअस होते हैं उन्हीं का सम तीसरे के बराबर होता है. ठीक है? ऐसे मैं एक बार पढ़ा रहा था, एक बच्चे ने कहा इसमें तो चलो ए बी है तो ए और बी का सम क्या हो गया? सी. लेकिन अगर मैं ऐसे कर दूं तो क्या होगा? किसका सम किसके बराबर है? नहीं, इसमें जो तीनों कंटिन्यूअस हैं तो तीनों कंटिन्यूअस है तो किसका सम किसके बराबर है? सॉरी, तीनों का सम 0 के बराबर है. ठीक है? तो इसको मैं ऐसे लिख सकता हूं ना, a प्लस बी प्लस सी इक्वल टू 0. डिस्प्लेसमेंट से समझाओ इसे. जब कोई इंसान जहां से चलता है वहीं वापस आ जाता है तो व्हाट इज द डिस्प्लेसमेंट? रिजल्ट भी वही है. ठीक है? इज इट ओके? इधर आओ. इसमें देखना दो का सम तीसरे के बराबर होगा. कौन से हैं दो? वो b plus r dash is coming out to be a, and therefore what is r dash? This is another very significant conclusion, that if one of the diagonal of a parallelogram represents addition, don't go away, the second diagonal is not useless, it is actually giving the subtraction. So एक तीर से दो निशाने हो जाते हैं पैरेललोग्राम में. आप बनाना पैरेललोग्राम तो है ही आपको, तो लगे हाथ आपने एडिशन भी निकाला और गिफ्ट में आपको रिटर्न गिफ्ट में सब्ट्रैक्शन भी मिल गया. तो नोट कर लो सेकंड मेरिट. डोंट डू दैट. डू एरो अदर साइड, दैट विल बी b माइनस ए. वो तो आपकी मर्जी. ये तो मैंने कहा नहीं, लेट अस चेक इट. तो आप चाहो तो एरो ऐसे ना बना के ऐसे बना लो, दैट विल बी b माइनस ए. चेक कर लेना. ऑब्वियसली अगर ये a माइनस बी है तो उसका उल्टा b माइनस ए ही होगा. ठीक है? तो एरो तुम्हारी मर्जी, तुम कहीं से बना लो, क्योंकि जब एरो बनाओगे तो एक चीज का ध्यान रखना है कि इन एनी ट्रायंगल द कंटिन्यूटी ऑफ टू वेक्टर विल रिजल्ट टू थर्ड वेक्टर, एंड इफ ऑल ऑफ देम आर कंटिन्यूअस देन इक्वल टू 0. ठीक है? करके दिखाऊं? चलो देखो. सपोज करो मैंने एरो ऐसे बना दिया. अब बताओ कौन कौन से दो कंटिन्यूअस हैं? तो लिखो a प्लस r डैश इज इक्वल टू b. क्या आ गया? r डैश वेक्टर इज इन एनी केस रिप्रेजेंट तो सब्ट्रैक्शन ही कर रहा वो, तो वो स्टेटमेंट मेरा अभी भी वैलिड होगा. व्हाट इज दैट? सेकंड मेरिट, दैट इफ वन in this parallelogram a and r dash is, just now I made it r dash, a and r dash continuous. See, ask actually arrow ऐसे क्यों बनाया था? If one diagonal represents addition, then other diagonal always represents subtraction. ठीक है? Is it okay? Before I move on, commutative law तो इसमें फॉलो नहीं हो रहा है. That means vectors subtraction is not commutative. ठीक है? Everything is not commutative. Vector addition is commutative, subtraction is not commutative. Before I move on, let's quickly learn. You can note down. Quickly learn these things. If two vectors are equal and they are actually inclined at 60 degree, what would be the resultant? जल्दी जल्दी लर्न करते हुए आगे बढ़ते हैं, बताओ जल्दी। ठीक है, जो आया रिजल्ट क्या आएगा, बार बार थोड़ी करेंगे, ये तो ऐसी चीजें जो याद होनी चाहिए। करो, कर लो, अगर याद नहीं तो कर लो, अभी निकाल के बता दो कितना आएगा। कितना आया? हाउ मच? कितना टाइम ले रहे हो यार? 2a, ठीक है, तो इसको याद कर लो, फिर ऐसे नहीं तो बार बार निकालोगे, अच्छा भी नहीं लगता, क्योंकि आप जेई की तैयारी कर रहे हो। तो 60 डिग्री पे दो वेक्टर हैं, तो रिजल्ट क्या होगा? a√3। ये ज्यादातर केसेस में मिलते हैं, इसलिए बता रहा हूं, क्योंकि 60 डिग्री इज एन एंगल। इफ यू कीप फॉलोइंग 3 वेक्टर्स इक्वल व्हिच आर मेकिंग ए 60 डिग्री, यू एंड अप फॉर्मिंग द इक्विलेटरल ट्रायंगल। ठीक है, व्हाट अबाउट दिस? ये भी याद कर लो, अगर दो इक्वल वेक्टर हैं और 90 डिग्री पे हैं, तो ये तो याद होगा। If they are at 90 degree, then what is the resultant? ठीक है, is it okay? Since I am taking equal vector, resultant will always bisect the angle, no doubt about it. ठीक है, now if two vectors are equal and directed in opposite direction, then what is the resultant? 0, a minus a. ठीक है, if two vectors are directed at 120 degree and they are equal, what is the resultant? करके देख लो, वो ultimately a आ जाएगा. That means the resultant will also be a. It's a very interesting case. Whenever two vectors are directed at 120 degree and they are equal, their resultant is also equal. ठीक है, कहीं भी कभी भी अगर ऐसा लिखा हो a प्लस b प्लस c प्लस d इक्वल टू 0 या प्लस e प्लस f इक्वल टू 0, what is the meaning of this? What is the meaning of that? They make a polygon. Definitely they will make a polygon, and that is why this law is known as the law of polygon or the vector law of polygon. In a polygon, it's always a plus b plus c plus d plus e plus f plus g plus h, whatever that comes out to be 0. ठीक है, is that okay? So make a polygon. Okay children, before I move on further practical, क्योंकि मैंने कहा था कुछ जो भी पढ़ रहे हैं उस practical example भी है. Can we now try to think of examples in our routine life where the parallelogram law, triangular law तो हमने बता ही दिया, 2-3 एग्जाम्पल, एक एग्जाम्पल अपने पापा का अपने दिया, डिस्प्लेसमेंट निकालना जहाँ भी, तो what about parallelogram law? Where directly we are using parallelogram law, examples where directly parallelogram law is used. And I can guarantee you that all the girls sitting over here, they might have done around 100 times by now in their life this example. But see how seriously now you're thinking, कौन सा example, क्योंकि practically सोचते ही नहीं कभी, पढ़ते बहुत ज़्यादा है लेकिन मेहनत बहुत करते हैं, लेकिन ये नहीं सोचते कि एक्चुअली जो पढ़ रहे हैं इसका प्रैक्टिकल यूज़ कहाँ है, किचन में या खेलते समय ग्राउंड में या फिर कहीं और है, या ड्राइंग रूम में है या वार्डरोब में है या कहाँ है, या स्विमिंग पूल में है या पतंग उड़ाने में है. लेकिन हाँ, स्विमिंग करना सब जानते हैं, नहीं जानते? okay. देखा होगा स्विमिंग करते हुए, कर भी लोगे, बहुत सिंपल है, अपने आप को पानी में डाल दो, स्विमिंग करना आ जाएगा, क्योंकि डूब के तो मरोगे नहीं, चिल्लाओगे या तो हाथ पांव मारोगे. एक्चुअली स्विमिंग की टेक्निकल डेफिनेशन हाथ पांव मारना ही होता है, तो आ तो गया, सिंपल. अब आपको इतना डर लगता है पानी में डालोगे नहीं, तो कोई अच्छा सा फ्रेंड पकड़ लो मेरी तरह, जो आपको एक थ्रो में, ठीक है, पानी में फेंक दे, और चूंकि बचा सकता है, जिसलिए कोई प्रॉब्लम, कॉन्फिडेंस है, तो ज्यादा से ज्यादा क्या चिल्लाओगे? हाँ जी, पानी फेंकने वाले, फिर भी स्विमिंग करना नहीं है अभी तक. इट्स वेरी गुड एग्जांपल ऑफ पैलोग्राम लॉ, swimmer swimming, because if you see that both the hands are moved in this backward direction, and these two hands are actually having some action, and as per Newton's third law, every action has equal and opposite reaction. So just be with me, one action, one force, say F1. अदर एक्शन, अगर दोनों हाथ बराबर नहीं चलते, ठीक है, तो F1 F2 दो अलग अलग लेता हूँ. तो F1 force and then another action F2 force, they are actually being acting at some angle. So where do you expect the resultant will lie?
Diagonal.
And where the swimmer goes?
Diagonally.
So exactly the direct example where the parallelogram law is being applied. The bird flies in the same way. Okay, and the bird knows better how to fly vertically up and how to fly in forward direction, because they just tilt their blades in such a way that they manage it, and then when they have to turn, see how they turn beautifully, the application of the parallelogram law. If you have to change the direction of resultant, one of the two vector has to be altered. So if the bird has to tilt in this direction, then naturally out of the two vector, एक वेक्टर इस तरह से चेंज होना चाहिए कि जो रिजल्टेंट है वो उस तरफ शिफ्ट कर जाए, और रिजल्टेंट हमेशा उसी की तरफ शिफ्ट करता है जो ज्यादा वाला होता है, ये भी याद रखना. रिजल्टेंट विल ऑलवेज शिफ्ट टुवर्ड्स द बिगर वन नेचुरली. इसकी लाठी उसकी भैंस. तो ऑब्वियसली स्विमर को भी अगर टर्न लेना है स्विम करते करते, सो दोनों रिएक्शंस को इस तरह से मैनेज करेगा कि स्विम कर ले. आप एक हाथ को डेलिबरेटली कभी स्विम करते समय स्विमिंग पूल में चलाओ ही मत, बहुत मजा आएगा. मैंने कई बार किया इसलिए करके बता रहा हूं मैं. होगा क्या, when I swim, I will always move in a circular motion. You know why? Because one of the force is missing, and every time I am generating a force, that force actually is a single force, and that single force is going to be centripetal force, which will make me to move in ऐसे एक्शन किया तो रिजल्ट इधर आया, तो I will be moving in this direction. फिर किया, फिर this direction, फिर किया, फिर I will just keep moving along the circumference, and I will move in a circular motion because the other hand is not moving. ठीक है. अनदर एग्जाम्पल, काइट, पतंग. इसका मांझा जो होता है, जो पीछे बांधते हो, धागा जो बांधते हो, ठीक है, उस धागे का जहां जंक्शन होता है उसमें दो धागे होते हैं, ठीक है. वो एक ऐसे थ्रेड होता है, एंड देन यू टाई अप दैट थ्रेड व्हिच एक्चुअली गोज इनटू योर दैट रील. So that thread actually balances the two thread tension. Tension in the two threads जो कि पतंग से ऐसे जुड़ा होता है, that actually is balanced by the other thread tension. अब अगर ये बैलेंस, अगर इसके स्ट्रक्चर में कुछ छेड़खानी करोगे तो आपका जो पतंग है कभी भी उड़ते समय बैलेंस नहीं रहेगा. इट विल बी डिसबैलेंस्ड, क्योंकि आपको बैलेंस बनाना है. उसका पोजीशन ऐसी होती है, धागा बांधते समय आप डिसाइड कर लोगे कि उसको ऐसी जगह करना है कि रिमेन द वेट ऑफ दिस रिमेन द काइट रिमेन्स इन दिस पोजीशन ऑल द टाइम. अनदर एग्जांपल, वी हैव गॉट पैरेललोग्राम law verification in laboratory, where you will be given 3 different weight with the help of weight boxes. Okay, and then you have to suspend all the 3 weights on a wooden platform, and the junction of the 3 threads, have you done this verification of parallelogram? Junction of the 3 threads, actually that is marked with the help of a plane mirror on a piece of paper with the help of pencil, and then you remove that paper and then you draw the, and then you verify the law of parallelogram of vector addition. Because what you expect, that the 2 different weight which you suspend over here, that 2 weights generate 2 tensions in the thread, and these 2 tensions, when they actually balance each other, resultant of the 2 tension, that actually makes balance with the third tension, third weight. So you calculate, D की हेल्प से आप एंगल निकाल लेते हो. अभी अभी जो फॉर्मूला पढ़ा, आप क्या करते हो, T1 स्क्वायर प्लस T2 स्क्वायर प्लस 2 T1 T2 cos थीटा, थीटा आप D से मेजर कर लेते हो. अब आपको ये थर्ड वेट पता है कितना है, वो तो नोन हो गया. अब अभी आपने क्या किया, दोनों वेट की हेल्प से, एंगल की हेल्प से फॉर्मूला अप्लाई करके ये निकाल लिया. एट द एंड ऑफ द डे क्या होना चाहिए, दिस कैलकुलेटेड रिजल्ट मस्ट बी इक्वल टू, सो यू हैव वेरीफाइड द पैरेललोग्राम लॉ इन द लैबोरेटरी. ठीक है. So that's direct applications of the parallelogram law, okay, as compared to triangular law. So this is more significant. I must say that this is more meritorious law in terms of adding 2 vectors as compared to triangular law. Nothing taking away the credit of the triangular law, because actually that does tell us how to find the displacement of 2 vectors. वो भी apply कर सकते हो जहाँ apply करना चाहो. ऐसी बात नहीं है, ठीक है. Should we move on? Now, if I separately tell you (60° a square plus a square plus 2a square cos 60°, and therefore I can say this is 2a square, ठीक है, 1 plus what is cos 60°? So this is 2a square root 3 by 2, I mean 3 by 2, so 2 cancel, this is a root 3. I want to separately tell you how to subtract two vectors, though there is no doubt that subtraction is nothing but the case of addition only. But see, when you want to have a separate process called subtraction, how do you do it? So see, learn how to subtract two vectors. Subtraction of two vectors. Vector A is given, vector B is also given. So what do you want? You want R A minus B. Yeah, let it be C. You want A minus B. Can I write A minus B as A plus of minus B? So why don't you find first minus B vector? It's very easy to find minus B. Opposite of B and equal in. So very simple. So if I have to find minus B vector, this is A vector, this is B vector, this would be minus B vector. So forget about this for the time being. So add them. How to add them? Using parallelogram law. What do you do? Draw. So this result will be obviously A vector minus B vector. Let us, for the sake of simplicity, complete the first parallelogram as well. इसको भी complete कर लो. इस parallelogram का ये था resultant. ठीक है? So what is this resultant? A plus B. This is A minus B. जो ये है वही ये है. ठीक है? तो इतना लंबा, इतना ज्यादा एक्स्ट्रा वर्क करने की कोई जरूरत नहीं है. दैट मीन्स उसी पैलोग्राम में हम हमेशा एक वेक्टर को अगर प्लस रिप्रेजेंट कर रहे हैं, दूसरे को ए माइनस बी कर सकते हैं. हाँ, डिबेट यहां होना चाहिए कि बड़ा कौन सा होगा. ये एक डिबेटेबल टॉपिक हो सकता है कि ए प्लस बी ज्यादा होगा या ए माइनस बी ज्यादा होगा या दोनों बराबर होंगे. दिस कुड बी लिटिल इंटरेस्टिंग. सो टेल मी whether a plus b is more or a minus b is more. Is it conditional or universal? हरदम या कभी कभी? क्या मुंडी हिलाने से हमें कैसे पता लगेगा क्या बोल रहे हो आप? कभी कभी. A plus b is always more than a minus b? जरूरी नहीं है. अच्छा, फिर कब a plus b ज्यादा होगा? चलो केसेस बताओ. a plus b ज्यादा कब होगा a minus b से? टेल मी द केस. Tell me the case when a plus b is more than a minus b का magnitude. अभी अभी पैरेललोग्राम बनाया था, दोबारा बना लो. इस पैरेललोग्राम में कौन सा डायगोनल बड़ा लग रहा है? ये जो डायगोनल बड़ा लग रहा है, ये बड़ा कब तक लगेगा? इसके बाद अगर जाओगे छोटा लगने लगेगा. करके देख लो. इसका मतलब थीटा जब तक एक्यूट है तब तक तो a प्लस बी विल बी मोर देन a माइनस बी. थीटा जब 90 है तो बराबर. थीटा जब obtuse होगा तो a प्लस बी becomes smaller than a minus b. Somewhere you need to note it down. So a plus b is more than a minus b when theta is less than 90 degree. A plus b is equal to a minus b when theta is 90 degree. and a plus b is less than a minus b when theta is more than 90 degree. तीनों केसेस. हाँ बेटा, ये वाला मुझे खुद ही नहीं पता मैंने क्या मिटा दिया. अच्छा, सब्ट्रैक्शन किया कैसे था? ए वेक्टर बी वेक्टर, हमें करना है ए माइनस बी. मैंने कहा आप इसे ए माइनस बी को ऐसे सोचो, ए प्लस ऑफ माइनस बी. ये अगर ये बी है तो ये वाला माइनस बी हो जाएगा, उसका जस्ट अपोजिट. अब इन दोनों वेक्टर को लेके एक पैरेललोग्राम बना लो. इसका जो रिजल्टेंट होगा यही तो होगा ए माइनस बी. ठीक है, मैंने ये कहा था कि यहां इतना करने के बजाय आप चाहते तो उसी पैरेललोग्राम को कंप्लीट करते, उसमें से एक डायगोनल ए प्लस बी होता, दूसरा क्या होता, क्योंकि जो ये है देखो वही ये है, मैग्नीट्यूड भी सेम है, डायरेक्शन भी सेम है, ये बताया था. ठीक है, अब जरा इसका केस ले लो. टेक दिस केस, बाकी दोनों केसेस तो आप जानते हो. टेक दिस केस, टेक टू वेक्टर्स and add them. Make a parallelogram law. Make a parallelogram. Which diagonal is going to be a plus b? And which one will be a minus b? That means which is more in magnitude? A minus b is more in magnitude. ठीक है? Is it okay? Can I also write a plus b is equal to a minus b if a plus b का mod is equal to a minus b का mod? Just give a break, 2 minutes दिमाग को ब्रेक देते हैं और आपसे हम कोशिश करते हैं, आप सोच के मुझे बताओगे कि is it, if this is true, is this, if this is true, then is this true? Whenever this is true, then can I conclude that even this is true? Meaning is, if a plus b ka mod is equal to a minus b ka mod, then can I say that a plus b vector is also equal to a minus b vector? Because when we defined equality of the two vectors, we said that two vectors will be equal when? So magnitude equal होने पे हम vectors equal कैसे कर सकते हैं? Direction अलग अलग है, हो सकता है, ठीक है? So that means if this is true, this is not true. Because this means magnitude तो same है लेकिन direction same नहीं है. ठीक है? Is it okay? Should I rub this, children? Yes, बेटा. कौन सा? ये? ठीक है, बताता हूं दोबारा. मैंने ये कहा कि एक वेक्टर A है, एक वेक्टर B है. इनको यूज करके आप एक पैरेललोग्राम बनाइए. ये डायगोनल बताओ क्या होगा? A प्लस बी. ये वाला डायगोनल क्या होगा? उनका मैग्नीट्यूड बराबर है, क्योंकि आपको पता है किसी रेक्टेंगल में दोनों डायगोनल हमेशा लेंथ में बराबर होते हैं. तो क्या चीज बराबर है? A प्लस बी का मॉड किसके बराबर है? बट ये दोनों वेक्टर आपस में बराबर कैसे हो सकते हैं? एक का डायरेक्शन ये है, एक का डायरेक्शन ये है. तो कहने का मतलब मेरा ये था कि a प्लस बी वेक्टर का मैग्नीट्यूड अगर a माइनस बी के मैग्नीट्यूड के बराबर हो है, इसका मतलब ये नहीं हुआ कि वो दोनों वेक्टर भी बराबर होंगे आपस में. ठीक है? अच्छा, अगर ये ट्रू है सपोज करो ये ट्रू है, ये ट्रू होगा क्या कभी? कैन दिस एवर बी ट्रू? a प्लस बी वेक्टर इज इक्वल टू a माइनस बी वेक्टर. एंगल जो मर्जी हो सोच लो, 0 डिग्री, 0 पे भी नहीं होगा. नहीं हो सकता. A plus B vector A minus B vector बराबर नहीं हो सकता. Actually, addition of two vector and subtraction, they can never be same. They will be same only in one case. And you know what is that case? When all of them are null vectors. That's the only situation when that is true. All of them are null vector. Naturally, null plus null is null and null minus null is also null. Okay. कैसे होगा? एक तरफ आप नल प्लस बी कह रही हो, नल प्लस बी, और दूसरी तरफ नल माइनस बी कह रही हो, तो बी इक्वल टू माइनस बी कैसे हो सकता है? ठीक है, ठीक है. हाँ. अच्छा, दूसरे को जो सबट्रैक्ट हो रहा है, जो ऐड हो रहा है, उसको नल कर दें. हाँ, तब हो सकता है. ए प्लस नल इक्वल टू ए माइनस नल, ये हो सकता है. वेरी गुड. ठीक है. ओके, नल पे ज्यादा दिमाग चलता है. Okay, children, let's multiply vectors now. The third है, fourth है, first, second, third, fourth. Multiply the vector. Fifth है. आप देख लेना नंबर क्या है. Multiplication of two vectors. We can multiply vectors by two different ways. A dot B is known as a scalar product. How do you write it? AB cos theta. And A cross B is vector product. How do you write? AB sin theta n cap. पहले आप इसे समझो. What is the meaning of this? A dot B, AB cos theta. We are actually multiplying in such a way that the resultant is having no direction. Okay, we must be doing because we might have been required somewhere in physics. Otherwise, ये तो एक जबरदस्ती की बात होगी. I'm writing A dot B as AB cos theta. So I'm asking this as a definition. Accept is a definition. A into B तो simple था. ये तो आप जानते थे कि A into B multiplication, लेकिन अचानक से cos theta आ गया. ठीक है, और कभी sin theta आ जा रहा दूसरे केस में. That means ये दोनों definitions आपको as it is अगर रटते हो तो definitely इसके पीछे कोई physics होगी. इन दोनों के पीछे देयर मस्ट बी सम फेनोमेना जिसकी वजह से डिफाइन की जाती है. पहले वाले के लिए जो फिजिक्स है वो है W इक्वल टू F डॉट D. व्हाट इज W? You cannot define work done until and unless actually you find the dot product of the force vector and displacement vector. Very simple. There are cases where यहाँ पर बताया गया, आपको हो सकता है ये चैप्टर हो गया हो अगर वर्क एनर्जी, तो टीचर ने बताया हो, there are cases where work is not done in spite of both the force and displacement are there. The case of Cooley, ठीक है. Now how do you explain this? Until and unless you have some logic, it's very difficult to explain common man कि the Cooley is not doing any work, and then you put a logic that cos theta is there, and if theta is 90 degree, what is cos 90? 0. So at least mathematically you are explaining it. At least mathematically you explain people that since cos 90 is 0, the work done by the Cooley is 0 because the weight of the object which the Cooley is carrying is acting in vertical direction and displacement is a forward direction. What is the angle between them? 90 degree. Fine. So this dot product is defined A, B cos theta. We call it a scalar product because the resultant is scalar. And another thing about it, can I write A dot B equal to B dot A? So can we say that the dot product is also commutative? लिखते जाओ. So the dot product of two vectors is commutative. Dot product result into a scalar. Dot product is commutative. Dot product results into a scalar. And the physical significance of dot product is, physical significance of finding dot product is work done equal to F dot D. This is physical significance. तीनों चीजें लिख ली. Dot product of two vectors is scalar. Dot product is commutative by nature, and the physical significance of finding dot product is actually the work done is dot product of force vector and displacement vector. Fine? Is it okay? I tell you another very important aspect of defining dot product. Just see this diagram. Okay, these are the two vectors. This vector B vector will have a component along A vector and vice versa. Even A vector will have a component along B vector. So when I actually say that a vector has a component along another vector, I give importance to one vector and I just neglect the other vector as far as the direction is concerned. Component निकालने का मतलब क्या हुआ? I am more interested in the contribution of this vector along the other one. ठीक वैसे जैसे एक बोलते कभी कभी बच्चों इनके पीछे पीछे लग लो, जहां जहां जाए वहां वहां जाना. वो बच्चा बेचारा छोटा बच्चा है और जिनके पीछे लगने की बात करें वो बड़ा है. तो वी एक्चुअली गिव लॉट ऑफ इंपॉर्टेंस टू वन एस्पेक्ट एंड वी इग्नोर. सो हमने कहा कि ये दो वेक्टर है, एक काम करते, लेट अस फाइंड द कंपोनेंट ऑफ दिस वेक्टर along this vector. Next time I might ask you reverse, component of this vector along other vector. So when I do that, only one component I'm asking, दूसरा नहीं बोल रहा हूं निकालने को, सिर्फ एक कंपोनेंट. ठीक है, क्योंकि दूसरा वाला जो होगा कंपोनेंट वो एक्चुअली इसके परपेंडिकुलर होगा. ठीक है, एक इसके अलोंग कर दिया. तो अगर मैं अलोंग ले लिया मैंने एक कंपोनेंट, बताना ए का कंपोनेंट बी के अलोंग क्या होगा यहां पर, ए कॉस थीटा, और बी का कंपोनेंट ए के अलोंग बी कॉस थीटा. अब बी के दूसरे कंपोनेंट को भूल जाओ, क्योंकि मैंने इस वेक्टर को सब कुछ मान लिया, इसका इंपॉर्टेंस इतना ज्यादा ले लिया मैंने, तो ऑब्वियसली इसका जो कंपोनेंट होगा वो भी इंपॉर्टेंट होगा मेरे लिए. अब मल्टीप्लाई कर दो, इधर भी करोगे तब भी ए बी कॉस थीटा, उधर करोगे तब भी ए बी कॉस थीटा. दैट मींस एक्चुअली डॉट प्रोडक्ट गिव्स टेल्स अस हाउ टू नलीफाई द इफेक्ट ऑफ डायरेक्शन वे यू आर मल्टीप्लाइंग. क्योंकि दो वेक्टर दो डायरेक्शन में है, ऐड करने के लिए तो मैंने लॉ बना दिया, ट्रायंगुलर लॉ, पैराबोलिक लॉ, थीटा निकालना सिखा दिया. अब मल्टीप्लाई करना है, तो मल्टीप्लाई करने के लिए डायरेक्शन का क्या करोगे? आपस में डायरेक्शन मल्टीप्लाई नहीं होते, ये कभी नहीं होता नॉर्थ इंटू ईस्ट इज वेस्ट, ऐसे कोई बेवकूफी नहीं कर सकता. ये कौन सा तरीका? तब तक कल कहोगे कि ईस्ट इंटू वेस्ट इज, कुछ भी कह लोगे ऐसे ही, वर्टिकल डायरेक्शन. तो डायरेक्शन का मल्टीप्लिकेशन ऐसे फिजिक्स का कोई कंसेप्ट नहीं है. अब यहां पर हम लोग अटक रहे हैं, कैसे कि वी हैव गॉट टू वेक्टर्स व्हिच आर बीइंग मल्टीप्लाइड. मैग्नीट्यूड का तो मल्टीप्लाई कर दे, डायरेक्शन का क्या करेंगे? तो करते हैं कुछ, नलीफाई करते हैं. सो वी जस्ट फाइंड द, जहां कर सकते हैं वहीं करेंगे, क्रॉस में नहीं कर पाऊंगा. क्रॉस में एक्चुअली एक दूसरा तरीका बताऊंगा कि कीपिंग डायरेक्शन आल्सो इन माइंड, हाउ टू फाइंड द प्रोडक्ट वेयर द रिजल्टेंट इज आल्सो हैविंग अ डायरेक्शन, वो क्रॉस में होगा. ठीक है, तो ये एक दूसरा तरीका था डॉट प्रोडक्ट को समझने का. समझ में आ गया? इज इट ओके? वर्क डन के सेंस में समझाऊं? बहुत आसान है. आपने इस मास पे ये फोर्स लगाया और आपने ये कहा कि मैंने सर इसको यहां से फोर्स लगा के यहां डिस्प्लेस कर दिया. रिजल्टेंट के सामने सोचना, लेट अस बी अ कॉर्पोरेट वर्ड, रिजल्टेंट ओरिएंटेड वर्ड. बच्चे ने फोर्स ये लगाया, फाइन, रिजल्ट क्या है? मास कहां से कहां गया? ठीक है, इज इट ओके? आपको लगता नहीं कि इस फोर्स का सिर्फ वही कंपोनेंट हमारे लिए इंपॉर्टेंट है जो डिस्प्लेसमेंट के अलोंग है, क्योंकि रिजल्ट तो हमें यहां दिख रहा है. इस कंपोनेंट का मैं क्या करूं एज फार एज द रिजल्ट इज कंसर्न? बिल्कुल यूजलेस है, मैं ये नहीं कर रहा हूं, आई एम नॉट सेइंग दैट यूजलेस है, क्योंकि लॉज ऑफ मोशन में पढ़ाऊंगा कि उसका कंपोनेंट नॉर्मल रिएक्शन को बैलेंस कर लेगा, ब्ला ब्ला, उसकी बात नहीं कर रहा हूं मैं सिर्फ ये कर रहा हूं रिजल्ट के एंगल से सोच के बताओ. एक फोर्स लगा लेकिन बॉडी इधर गई. ठीक है, तो अगर इस फोर्स से बॉडी इधर गई तो इस फोर्स का कौन सा हिस्सा होगा, विच कंपोनेंट विच इज सिग्निफिकेंट, इंपॉर्टेंट, ऑब्वियसली तो लो ना एफ कॉस थीटा. तो फिर मल्टीप्लाई करो, वर्क डन क्या होता है? फोर्स इनटू डिस्प्लेसमेंट, बट विच फोर्स? द फोर्स विच इज सिग्निफिकेंट. सो एफ कॉस थीटा इनटू डी. So tell people that I have got a product method, and what is that method? Dot product. How to do it? F dot D is FD cos theta. ठीक है, is it okay? अगर गलती से ये फोर्स इधर लग गया, लगा दिया, हमें क्या पता था इधर ले जाना है. So tell me, ऑब्जेक्ट फोर्स इधर लगाया, चाहते थे इधर ले जाना, चाहते इधर, फोर्स इधर लगा दिया, बताना मास जाएगा किधर? हो सकता है और फोर्स लगाओ, कभी अगर जाए, अब कभी गया तो ठीक है, ले जाना इधर चाह रहे थे, ले जा इधर रहे. इज इट अ कॉर्पोरेट वर्ल्ड? इज इट अ रिजल्ट ओरिएंटेड वर्ल्ड? तब तो नौकरी से निकाल दिया जाएगा. सो आई विल जस्ट शाउट एट द परफॉर्मर, पागल हो गए हो, कर क्या रहे हो, तूने कुछ भी नहीं किया, कुछ भी नहीं किया, जो करना था नहीं किया, कर क्या रहे, कुछ भी नहीं किया, मतलब व्हाट इज द वर्क डन? सो इफ थीटा इज 90 डिग्री, व्हाट इज द वर्क डन? जीरो. तो वो हम सिखाते हैं लोगों को. ठीक है, is it okay? So this is another way of understanding how to define cross dot product as f dot d as f d cos theta or a dot b as a b cos theta. Come to the cross product. What is n cap? Tell me. What is n cap here? Okay, unit vector in which direction? Normal to what? Normal perpendicular to what? Both vector A and somebody might also call, इस पूरे सेंटेंस को, इस पूरे लाइन का एक मतलब और निकला. What is that? Perpendicular to what? Plane containing vector A and vector B. ठीक है, क्योंकि दो लाइन हमेशा एक प्लेन में होते हैं. अगर आप कहते हो कि इन दो लाइनों के परपेंडिकुलर एक तीसरी लाइन है, दैट मीन्स यू आर सेइंग दैट कि इस प्लेन के परपेंडिकुलर वो लाइन है. Two lines always lie in a single plane. So perpendicular to both of them means perpendicular to this plane where both of them are lying. Fine. Is it okay? Definitely इस तरह का कहीं पर फिजिक्स में रिक्वायरमेंट आया होगा, जैसे मैंने यहां समझा, तभी जाकर इस तरह की डिफिनेशन बनी. ऐसा कुछ केस जरूर होगा जहां पर टू वेक्टर्स आपस में मल्टीप्लाई होते हैं, मतलब आपस में मिलते हैं और रिजल्ट वेक्टर होता होगा, जैसे टॉर्क. ठीक है, उसमें रेडियस वेक्टर एंड फोर्स वेक्टर जब मल्टीप्लाई होते हैं तो वी गेट अनदर वेक्टर, अनदर रिजल्टेंट वेक्टर. समझाना थोड़ा सा डिफिकल्ट हो सकता है मेरे लिए भी, आपके लिए समझना है, क्योंकि जैसे वर्क डन आसानी से समझा लिया, वैसे टॉक का डायरेक्शन निकालना इतना आसान नहीं है. क्योंकि दरवाजे वाले केस में ज्यादातर लोग फंस जाते हैं, क्योंकि दरवाजे में घूमता तो है दरवाजा, लेकिन टॉक का डायरेक्शन किधर है पता नहीं चलता. कुछ लोग सोचते हैं हिंजेस जहां लगा उधर है, कुछ और ही रिजल्ट आता है कभी कभी. फिर एक और एग्जांपल है टॉक का, जिसमें वो मिट्टी बनाने वाला जो एक सिस्टम नहीं होता, मिट्टी का बर्तन बनाता है, उसमें गीली मिट्टी क्ले रख देते हैं बीच में और उसको घुमाकर ऐसे रोटेट करके छोड़ देते हैं और उसको इशारे से इसको पकड़ के ऐसे होल्ड करके रखते हैं. देन सडनली दे गेट द क्ले कमिंग आउट, और उसको शेप देना ऑब्वियसली उन्होंने सीख रखा है ऐसे, तो सीख के ऐसे ऐसे करके फिर उसको निकाल के बाहर रख देते हैं. वो कभी कप बन जाता है, कभी वो सुराही बन जाती है, कभी कुछ और घड़ा बन जाता है. बट द क्वेश्चन अराइजेस दैट ऊपर कैसे आता है, क्योंकि ऊपर वो लेकर नहीं आते होंगे, हो सकता है कुछ फोर्स लग रहा हो, कुछ रिजल्ट लग रहा हो दोनों का, तभी तो ऊपर आता है. और अगर उसे क्लॉकवाइज घुमा दें, एंटी क्लॉकवाइज ना घुमाएं, तो कितनी भी कोशिश कर लो ऊपर निकालने का, ऊपर ने मिट्टी फैल जाएगी पूरे सरफेस पे, लेकिन आएगी नहीं ऊपर. ठीक है, कभी मौका मिले आप लोग अगर कभी तो करके करा के कोशिश करके देखना. So there must be cases where two vectors, when they act together, they result into third vector. And the third vector, not only this, the third vector might be occurring in a direction perpendicular to both of them. So we need to define now such kind of product where two vectors multiplied, fine, but the resultant has to be vector. So we define like this. The examples R cross F is torque. ठीक है, is it okay? Another example is dB vector, 12th में पढ़ोगे, is mu naught upon 4 pi I dl cross r cap upon r square. This is magnetic field. Right hand side में ये सारे constant हैं. These are constants. I is current, dl is length, r is radius. Okay, unit vector and this is radius. यहाँ पर what is r? Radius vector, f is force vector. ठीक है, ये हमने दो एग्जांपल्स दिए जहां पर हम क्रॉस प्रोडक्ट निकालते हैं. ठीक है, is it okay? Tell me, a cross b will be, if it is AB sin theta, if theta is 0 degree, then what is A cross B? 0. ठीक है, if theta is 90 degree, then what is A cross B? AB. Okay, n cap. If theta is 180 degree, what is A cross B? What is sin 180 degree? 0. Okay, cos 180 is -1. So sin 180 is 0, so this is also 0. A cross B is 0. What is the meaning of theta 0 degree in terms of two vectors? They are parallel. What is the meaning of theta 180 degree? So that means the result, what result says, two vectors, whether they are parallel or anti-parallel, their cross product will always be 0. ठीक है? एक और फिजिकल सिग्निफिकेंस बता देता हूं. Before I tell you that physical significance, I want to know that how many of you know the method to find the area of a parallelogram. How to find the area of this parallelogram? Not trapezium. I'm asking parallelogram. Base into? So what is the height here? If this is theta, so height will be? So आपने कहा कि area of a parallelogram is AB sin theta. So can I write A cross B का mod? So what is the physical significance of having cross product of two vector? Actually, when you find the cross product of two vector, magnitude of that cross product happens to be what? Area of a parallelogram whose two adjacent sides are making the parallelogram. ठीक है? Two vectors. ठीक है? Note कर लो कहीं पर. The physical significance of cross product of two vector is that the magnitude of the cross product of two vectors happens to be the area of parallelogram, whose two adjacent sides are represented by the two vectors. Children, can I write A cross B equal to B cross A? Can I write this? If yes, then I think cross product is also commutative. If no, then it is not commutative. But who will decide yes or no? Before you decide yes or no, you have to first tell me that how to find the n cap direction, because as far as AB sin theta is concerned, वो तो दोनों केस में सेम होगा क्योंकि मल्टीप्लिकेशन है AB sin theta का, तो इट इज द n cap जो प्रॉब्लम कर सकता है. पहले n cap डिसाइड करते हैं. हाउ टू फाइंड? आपने कहा n cap बताया था आपने अभी कुछ. n cap is what? Perpendicular to both A and B. So if I have a plane, how many perpendicular? This is a plane in front of you. How many perpendiculars can be defined for this plane? How many direction of perpendicular? कुछ लोग सोच रहे होंगे इनफाइनाइट. मैं एक ही डायरेक्शन में इनफाइनाइट परपेंडिकुलर को सेम कैटेगरी में एक ही हुआ वो. ठीक है? 2 ओनली. ठीक है? बोले सर इनफाइनाइट 2 हुआ क्योंकि एक आपकी तरफ, दोनों परपेंडिकुलर हैं. ठीक है? ये जानना जरूरी है कि आउट ऑफ द 2 पॉसिबल डायरेक्शंस ऑफ परपेंडिकुलर एन कैप एक्चुअली कौन सा होगा. इसका मतलब उतना कहने से सफिशिएंट नहीं होता जितना आपने कहा था. आपने ये तो कहा था कि परपेंडिकुलर टू बोथ ए एंड बी, तो उससे 2 ऑप्शन हो सकते हैं. अगर ये 2 वेक्टर्स हैं, कैमरा, अगर ये 2 वेक्टर्स हैं सपोज, इनके 2 परपेंडिकुलर होंगे, एक ऊपर एक नीचे. अब ये जान लेते हैं कि ए क्रॉस बी में कौन सा एक्सेप्ट करते हैं. क्योंकि फिजिक्स से रिलेटेड ये डेफिनेशन है तो वहीं से आया होगा ये. तो जो मैं बताना जा रहा हूं ये एक्चुअली बताने का एक नोशन हो सकता है, याद कराने का एक तरीका हो सकता है, लेकिन इसमें कोई इंटेलिजेंस इन्वॉल्व नहीं है कि हम जानते थे आप नहीं जाने. ये बस एक तरीका है, याद कराने का तरीका, क्योंकि हो सकता है इसी तरह से करने से आता हो रिजल्ट. ठीक है? तो अगर मैं ए क्रॉस बी इसमें निकालू, इस डायग्राम में ये ए है ये बी है, ए को बी की तरफ घुमाऊं, अगर मैं ए को बी की तरफ घुमाऊं, इसी को तो आप कह रहे हो क्रॉस ए क्रॉस बी, तो जिधर थंब होगा दैट इज द डायरेक्शन ऑफ एन कैप. तो इस केस में ए क्रॉस बी किधर हो गया? ऊपर. बी क्रॉस ए निकालना, सो हाउ कैन ए क्रॉस बी विल बी बी क्रॉस ए? एक्चुअली So what is the conclusion? Cross product is not commutative. नोट कर लो कहीं पर, क्रॉस प्रोडक्ट इज नॉट कम्यूटेटिव. और इस रूल का नाम लिख लो कहीं पर, लिख लो नीचे, रूल टू फाइंड द डायरेक्शन ऑफ एन कैप. नीचे नोट करो, रूल टू फाइंड द डायरेक्शन ऑफ एन कैप. Rule to find the direction of n cap. Rule लिख लो, right hand thumb rule. So A cross B is in this direction. Upward direction is dot circle, and in the same direction A cross B is AB sin theta n cap dot circle. इसी में अगर B क्रॉस A निकालना हो, this is BA sin theta minus n cap, and minus n cap is a cross circle. What is the meaning of dot circle and cross circle? Dot circle is something which is towards you, and cross circle is something away from you. Very simple to remember. If I throw an arrow to you, definitely you will be able to see the dot of the arrow, and I will be able to see the cross of the arrow. Cross, you know, पीछे arrow का पीछे वाला. So something which is going towards you has to be represented by dot, and for me something which is going away from me, तो इस बोर्ड की तरफ जो आएगा ऊपर की तरफ, that has to be dot. बोर्ड से नीचे जो जाएगा that has to be cross. एक और भी बड़ा आसान तरीका याद करने का, जब मैं A क्रॉस B करता हूं तो am I doing clockwise या एंटी क्लॉकवाइज? ठीक है, एंटीना सब साथ छोड़ देंगे आपका. एक चीज जो आपका साथ नहीं छोड़ेगा वो पेन है. ठीक है, तो अगर पेन को घुमाओ, घूमे तब तो घुमाओ, खुलता ही है, दूसरा तो जो खुल जाए. ठीक है, अगर इसे मैं घुमाता हूं और एंटी क्लॉकवाइज घुमाता हूं तो ये मेरे हाथ में आ जाएगा होपफुली. ठीक है, हाथ में आने के बाद ऊपर की तरफ तो डॉट, और घुमाया कैसे? एंटी क्लॉकवाइज. तो जब कभी ए क्रॉस बी निकालना हुआ तो चेक कर लेना, ए क्रॉस बी निकालते समय एक्चुअली आप उसे ए क्रॉस बी को एंटी क्लॉकवाइज कर रहे हो या क्लॉकवाइज कर रहे हो. तो एक ए से बी की तरफ जाओ, आपको लगता नहीं ए से बी की तरफ जा रही हो, तो घड़ी तो देखा होगा चलते हुए. सॉरी, ठीक है, घड़ी जैसे चलती है उसका उल्टा अगर हो रहा है तो एंटी क्लॉकवाइज. I know you didn't mean this, but and if it is going along the clock, then clockwise. So see, A cross B. Am I going as if the clock goes, yeah, opposite to the clock? So call it B cross A. ठीक है, इस केस में, पेन के केस में तो आपको पता ही चल जाएगा. पेन को घड़ी चूंकि ऐसे रखी, ऐसे देखना. डायरेक्शन निकालने के लिए, मतलब उसी का द सेम जो मैंने राइट हैंड थंब रूल बताया. राइट हैंड थंब रूल अगर याद ना रहे या नहीं अप्लाई करना चाहते हो तो ये भी एक सेंस हो सकता है क्लॉकवाइज. सो व्हेन यू, और ये जो बता रहा हूं ये इसलिए बता रहा हूं क्योंकि इसका फिजिकल सिग्निफिकेंस हो गया. डेफिनेटली अगर हमें मिट्टी को ऊपर ले आनी है तो जो वो डिस्क है जिसके ऊपर हमने गीली मिट्टी रखी है, क्ले, दैट हैज टू बी रोटेटेड इन एंटी क्लॉकवाइज. ठीक है, इज इट ओके? सो दिस एंड देन यू रोटेट इन क्लॉकवाइज, इट गोज डाउन. ठीक है, ये लो जैसे लिया था वैसे दे दिया. फाइन चिल्ड्रन, इज इट ओके? द लास्ट टॉपिक, एंड दैट इज रेजोल्यूशन ऑफ अ वेक्टर. How to resolve a vector? The meaning of resolution, simple meaning of resolution is when you look a vector as if it is made up of many other vectors. Resolution, वैसे literal meaning of resolution is making more clear. Resolving means making more clear. Something which is not that clear, you make it more clear. So that is all resolution. And how do you make more clear? Suppose a vector, and I say that vector is actually made up of 3 different vectors. So make it more clear. Break them. Show me where are those 3 vectors. So the process is known as resolution. It's very simple to do it. If I know in which direction I have to resolve, I can easily do it. If you say that resolve in a plane, okay, so I can preferably choose the resolution for two perpendicular direction, say one along x-axis, another along y-axis. So planar resolution. Okay? I'm not saying that you cannot have a component of this vector in any other direction in this plane. हो सकता है यहाँ कोई वेक्टर का कंपोनेंट आपसे पूछने, but it's very simple to resolve. अगर मैं a का कंपोनेंट इसके along निकालना चाहता हूँ, this will be a cos theta और ये हो जाएगा a sin theta. पाइथागोरस थ्योरम यूज करो तो ये आ जाएगा. ठीक है? Is it okay? Now since it is along x axis, मैं डायरेक्शन में इंटरेस्टेड हूं. अभी तक मैग्नीट्यूड था. कौन सी ऐसी चीज से मल्टीप्लाई करूं कि इसका मैग्नीट्यूड भी ना चेंज हो और डायरेक्शन भी पता चल जाए? I cap. What is the magnitude of I cap? 1. So multiplying by 1 will not change the magnitude of a cos theta, whereas just I write I cap means it is actually directed along x axis. What should I write here so that it becomes a vector? That means if I have to write vectorially, then these are the two components of the vector, one along x axis, one along. Let us make the triangular law again working. In this triangle, these two sides are continuous. So this plus this will be this. जो ये है वही ये होगा. So this is j cap a sin theta. So continuous जो है उनको लिखो. What are continuous here? I cap a cos theta and j cap a. That means a vector can be resolved as I cap a cos theta and j cap a sin theta in a plane, not in a space, in a plane. Can I also write this as I cap ax, j cap ay? And whenever I have to ask you magnitude, using Pythagoras theorem quickly, how do you write the magnitude? Simply factor of I cap, factor of j cap, दोनों का square and then square root. ठीक है? ये नोट कर लो. So this was the resolution actually in a plane. You can have as many number of components possible, but at a time when you want to resolve, then it's better to have a two components so that you can apply the Pythagoras theorem. Otherwise तुम किसी भी एंगल पे करना चाहो, सपोज करो मैं आपसे कहता हूँ इस कंपोनेंट के डिफरेंट डायरेक्शन में कंपोनेंट निकालो, तो आप पूछोगे सर बताओ कहाँ कहाँ निकालना है, तो मैं बोलूंगा एक बार 30 पे निकालो, तो आप कहोगे सर a cos 30. कहूंगा एक बार 120 पे निकालो, a cos 120. 150 पे निकालो, a cos 1. सिंपल, आप उसे रिजॉल्व करते जाओ. मतलब जो कंपोनेंट होता है एक्चुअली वो कॉस ही होता है. साइन तो इसका कंपनसेटरी कंपोनेंट है, लेकिन ये दोनों मिलकर ये बनाएंगे, ये पक्का है, यूजिंग द पाइथागोरस थ्योरम. ठीक है? इज दैट ओके? तो फिर हमें उसको स्पेस में, वेक्टर को स्पेस में लेना होगा, क्योंकि हो सकता है वेक्टर स्पेस में ना हो. और अगर वेक्टर स्पेस में नहीं है, सपोज करो एक वेक्टर है जो कि इस प्लेन में है, तो इस वेक्टर का जेड डायरेक्शन में कंपोनेंट 0 होगा. क्यों? क्योंकि जिस लॉजिक से मैंने अभी इसको समझाया, कोई भी कंपोनेंट को मैं कर रहा हूं a cos थीटा ले लो, तो इसका कंपोनेंट जरा इधर लेना, a cos 90 तो लोगी. तो व्हाट इज cos 90? तो इसका मतलब स्पेस में अगर वेक्टर है तभी जाकर उसके 3 कंपोनेंट हो सकते हैं. अगर स्पेस में नहीं है तो 3 कंपोनेंट हो ही नहीं सकते. ठीक है? इज इट ओके? चलिए वन मोर थिंग. थोड़ी देर पहले आपने मुझे बताया था पोजीशन वेक्टर. ठीक है? सो इट इज नॉट अ पोजीशन वेक्टर. इफ आई राइट द कोऑर्डिनेट ऑफ दिस इज 3,4, व्हाट इज द मीनिंग ऑफ दिस कोऑर्डिनेट? कर लिया होगा ना? सो वेयर इज 3 इस डायग्राम में, एंड वेयर इज 4? So what is this length? Pythagoras theorem से 3 square plus 4 square. ठीक है? So keeping everything in mind, if I know the coordinate, I can easily write the position vector 3i cap plus. So this is how we convert the coordinate geometry into position vectors. ठीक है? If the coordinate is given, position vector can easily be written. If the position vector is given, coordinate can be easily written. ठीक है? Is it okay? एक और बात, tan थीटा क्या होगा इस डायग्राम में? व्हाट इज tan थीटा? ऑब्वियसली वो तो कट जाएगा, a tan थीटा आएगा। लेंथ के हिसाब से बताओ, ए वाई बाई, ठीक है, tan थीटा इज ए वाई बाई ए एक्स। ऑब्वियसली थीटा tan इनवर्स ए वाई बाई ए एक्स हो जाएगा, ठीक है। 2 माइनस 3, इसको जरा वेक्टर फॉर्म में लिखो, पोजीशन वेक्टर, जल्दी बताओ। पोजीशन वेक्टर क्या होगा? 2i कैप, इसका मैग्नीट्यूड बताओ, मैग्नीट्यूड, इसका डायरेक्शन बताओ, tan थीटा, बोलो, -3/2, इसलिए थीटा इज इक्वल टू, ठीक है, इजी है ना? फाइन, दैट मीन्स यू नो द कोऑर्डिनेट, यू कैन फाइंड द position vector and therefore the direction of the vector. Let us resolve the vector into space. Spatial resolution. Children, I am doing it. I hoping that आपको ये पता होगा कि जेड एक्सिस मैंने यहाँ दिखा, एक्चुअली यहाँ नहीं है, ये ऐसे है, ठीक है। इसको मैं भले ही यहाँ दिखा रखा हूँ, जब भी मैं ड्रॉ करूंगा इस तरह से समझना। तो अगर ये जेड एक्सिस ऐसे है जैसे मेरा पेन है, तो और ये जो वेक्टर ए है, ये वेक्टर एक्चुअली इस प्लेन में नहीं है, ये ऐसे है, ठीक है। तो ये मेरा डस्टर वेक्टर ए है, और ये जो मेरा पेन है, इस केस पेन, दैट इज वेक्टर, दैट इज जेड डायरेक्शन, ठीक है। कीपिंग दैट इन माइंड आई एम ड्राइंग इट, आप भी उसे समझना। सो आई एम ड्राइंग द परपेंडिकुलर on the zx plane. यहां आके रुकूंगा। I have drawn the perpendicular from this tip of the vector A, and that perpendicular का मैं zx plane में foot चाह रहा हूं, foot of perpendicular यहां होगा। Join the origin with this, ठीक है। I am drawing a perpendicular from here to x axis. I am drawing a perpendicular from here to z axis. ठीक है, 90 degree, and even this angle is 90 degree if I am not wrong. Why? Because this lies in this zx plane. ठीक है, is it okay? दोबारा समझाऊं? ये वेक्टर A जो है ये ऐसे है, तो ऑब्वियसली, और ये जो स्केच पेन मेरा ऐसे है, भगवान ने दो यहाँ दे रखा है, इसलिए एक साथ बहुत सारे क्रियाकलाप यहाँ नहीं कर सकता, कुछ आपको समझना ही पड़ेगा। तो ये जो स्केच पेन वाला डायरेक्शन है, ये आप अंडरस्टूड है, आप सोच के रखो। और ये जो डायरेक्शन है, ये मैंने दिखा दिया, वेक्टर ए है, इसके टिप से मैं नीचे जाना चाह रहा हूं, और इस एक्सिस और इस एक्सिस के प्लेन में एक पॉइंट ढूंढना चाहूं जो फुट ऑफ परपेंडिकुलर होगा। तो ये हो गया, ठीक है। नेचुरली जहां जाकर एंड होगा, वहां से अगर मैं ओरिजिन पे ज्वाइन करूंगा, तो ये वाली जो लाइन है, ठीक है, ये वाली जो लाइन है, ये और ये वाली जो लाइन है, आपस में दे विल बी परपेंडिकुलर। नाउ इफ आई फॉलो दैट कंटिन्यूटी रूल इन अ ट्रायंगल, टू कंटिन्यूअस वेक्टर्स रिजल्ट इनटू, सो इट्स वेरी सिंपल टू अंडरस्टैंड द रेजोल्यूशन इन स्पेस। आप देखते जाओ, ये जो एक्स एक्सिस है, इसकी तरफ ये जो कंपोनेंट, उसको मैं आई कैप ए एक्स लिख सकता हूं। ये जो कंपोनेंट होगा, इसको मैं के कैप ए जेड लिख सकता हूं, और ये जो कंपोनेंट होगा, ये आई कैन राइट दिस एज जे कैप ए वाई, बिकॉज दिस हैपेंस अलोंग वाई एक्सिस, ठीक है। इज इट ओके? नाउ टेल मी, इन दिस ट्रायंगल, look at the triangle, in this triangle, how to write this? This plus this is this is parallel to this, and therefore k cap az plus I cap ax is equal to this. So इसको अगर मैं c वेक्टर मान लूं, तो c वेक्टर क्या हो गया, k cap az plus I cap ax। अब ये वाली ट्रायंगल देखो, ठीक है, दिस ट्रायंगल, लुक एट दिस ट्रायंगल, दिस प्लस दिस इज दिस, कंटिन्यूस है दोनों ये, तो आई कैन राइट ए वेक्टर इज इक्वल टू सी वेक्टर प्लस j cap ay. What is c vector? So ultimately the component which has got been which have got resolved is, so vector a in space can be written as I cap ax plus j cap ay plus k cap az. जिनको समझ में नहीं आया हो वो इसे इससे समझेंगे, यहां समझ लो चाहे घर जाके समझ लेना, तो बहुत आसानी समझ में आ जाएगा। ठीक है, आप इस डायग्राम से समझोगे तो सब कुछ समझ में आ जाएगा। इसमें ये y एक्सिस है, ये z एक्सिस है, ये x एक्सिस है, ठीक है, ये कॉर्नर है, यहां से मैं इसके सामने वाले अपोजिट कॉर्नर को ज्वाइन करके जो वेक्टर डिफाइन कर रहा हूं वो वेक्टर कौन सा है, a वेक्टर है। नेचुरली x की तरफ जो कंपोनेंट है वो i ax है, ठीक है, ये वाला जो कंपोनेंट होगा वो j ay होगा, और ये वाला जो कंपोनेंट है वो k az होगा। ठीक है, इज इट ओके? इसकी हेल्प से समझोगे तो दिस विल नाउ यूज द पाइथागोरस थ्योरम ट्वाइस। इट्स राइट एंगल ट्रायंगल, इट इज आल्सो राइट एंगल ट्रायंगल। ठीक है, यहां देखो ये राइट एंगल ट्रायंगल है, इसमें अगर मैं पाइथागोरस थ्योरम अप्लाई करूं तो नेचुरली मॉड ऑफ सी क्या होगा, व्हाट इज मॉड ऑफ सी, az स्क्वायर प्लस ax स्क्वायर का अंडर रूट, और इस वाले राइट एंगल ट्रायंगल में पाइथागोरस थ्योरम अप्लाई करो, ये 90 डिग्री है, सो दिस स्क्वायर प्लस दिस स्क्वायर विल बी दिस स्क्वायर, इसका स्क्वायर ये है, ठीक है, और इसका स्क्वायर हो जाएगा ऑब्वियसली ay स्क्वायर। अल्टीमेटली आई विल गेट a एज स्क्वायर रूट ऑफ ax स्क्वायर प्लस ay स्क्वायर प्लस az स्क्वायर। ठीक है, कंक्लूजन इज वेरी सिंपल, किसी भी वेक्टर को अगर स्पेस में रिजॉल्व करते हो, वेरी इजी टू रिजॉल्व, diagrammatically it could be tough but process wise it's very simple. How to resolve it? I component, j component, k component. How to find the magnitude? Square root of factor of I component का square, j component का square, k component का square. ठीक है, is it okay? If I convert into position vector, so if there is a point whose coordinate is 2, 3, 4 and I want to resolve it, vector A, how to find vector A, tell me? 2i cap, what is the magnitude? ठीक है, डायरेक्शन का बहुत सीरियस पंगा है, जैसे वहां आराम से tan थीटा आपने बता दिया वैसे यहां नहीं बता सकते। व्हाट इज द रीजन? क्योंकि जो वेक्टर है एक्चुअली वो स्पेस में है, और जो स्पेस में वेक्टर है एक्चुअली वो दो अलग अलग वेक्टर के साथ एंगल बना रहा है, दोनों अलग अलग प्लेन में है। ठीक है, लेकिन इसका मतलब ये नहीं होगा कि डायरेक्शन होगा ही नहीं, डायरेक्शन होगा इसका भी, लेकिन इसके डायरेक्शन को हम लोग जैसे डिफाइन करते हैं उसको डायरेक्शन कोसाइंस कहते हैं। क्या कहते हैं? डायरेक्शन कोसाइंस। ठीक है, वो प्रॉब्ली इट्स अ सब्जेक्ट मैटर फॉर द नेक्स्ट क्लास। डायरेक्शन निकालने के लिए डायरेक्शन कोसाइंस की हेल्प से हम डायरेक्शन कोसाइंस निकाल के फिर उसका डायरेक्शन निकाल सकते हैं। ठीक है, मैग्नीट्यूड निकालना बता दिया और रिजॉल्व करना सिखा दिया मैंने आपको। जो चीजें मैंने बताई अभी लास्ट में 5 मिनट में रिजॉल्व करके, आई कैप, जे कैप, के कैप, अल्टीमेटली वेक्टर की ही भाषा है। अब तक जो इसके पहले मैंने 2.5 घंटे पढ़ाया, लगभग 2 घंटे 25 मिनट, उसमें वेक्टर से काम करना बहुत मुश्किल है, लेकिन आई कैप, जे कैप, के कैप के टर्म में इट्स सो इजी टू फाइंड द वेक्टर एडिशन, वेक्टर सब्ट्रैक्शन, वेक्टर डॉट, वेक्टर क्रॉस। Most of the cases actually when you do in your physics problem, you actually go for I cap, J cap, K cap. I tell you how. Suppose को मैं कहता हूँ एक वेक्टर है जो 3i cap plus 4j cap है, ठीक है। एक दूसरा वेक्टर है जो 2i cap plus 2j cap है, दोनों को ऐड करना है। अगर ये कंपोनेंट दिया नहीं होता तो ऐड करने को अगर मैं बोलता तो आप उससे ऐड करते, a प्लस बी वाला जो मैंने शुरू में बताया था, a स्क्वायर प्लस बी स्क्वायर प्लस 2ab cos थीटा, फिर tan अल्फा निकालते, b sin थीटा, उसमें थोड़े बहुत तो लफड़े थे, आगे आपको अलग बात है, बट लुक एट द हार्ड वर्क विच यू डू। पहले तो आप पैरेललोग्राम बनाओगे या ट्रायंगुलर लॉ लगाओगे तो ट्रायंगल बनाओगे, ठीक है। एंगल मैंने यहाँ दिया नहीं, एक और मुसीबत, क्योंकि हमने वेक्टर का कंपोनेंट दे दिया। आई सेड वेक्टर 3i कैप प्लस 5j कैप, 2i कैप प्लस 2j कैप, एंगल तो मैंने दिया ही नहीं। लेकिन एंगल नहीं दिया फिर भी एंगल निकाल सकते हो, बट एंगल निकालने के बाद इट्स अनदर हेडक। एक वेक्टर का एंगल, दो वेक्टर का एंगल आपने x निकाल लिया, फिर दोनों वेक्टर को ड्रॉ करोगे पैरेललोग्राम में, देन फॉर्मूला अप्लाई करोगे एंड देन रिजल्टेंट निकालोगे, फिर डायरेक्शन के लिए tan अल्फा निकालोगे। सिंपल। अब देखो I and I can be added because they are like components, and j and j can be added. So if I say that a vector A is 3i cap plus 5j cap, a vector B is 2i cap plus 2j cap, add them. How easy? Do it, simple. And somebody might say, अच्छा ये तो तेरा रिजल्टेंट आया नहीं, रिजल्टेंट बताओ, तो बोले कौन सी बड़ी बात है, I कंपोनेंट का स्क्वायर प्लस B का स्क्वायर रूट। We are exempted from using that formula. Which one? A square plus B square plus 2ab. रही बात डायरेक्शन की, since it's only two component, we can always write tan theta equal to ay by ax. ठीक है। अगर मैं आपको ये सिखा दूं कि I डॉट I कैसे निकालते हैं, J डॉट J कैसे निकालते हैं, K डॉट K कैसे निकालते हैं, फिर तो A डॉट A निकालना भी बहुत आसान हो जाएगा, क्योंकि कौन जाए A डॉट B इक्वल टू ए बी कॉस थीटा, क्योंकि क्या क्या चाहिए हमें, A चाहिए, B चाहिए, कॉस थीटा भी चाहिए। लेकिन अगर आपको सिर्फ ये आ जाए हाउ टू फाइंड I डॉट I, J डॉट J, K डॉट K, फिर तो डॉट प्रोडक्ट भी इसी से निकाल लेंगे। I क्रॉस I अगर आ जाए, J क्रॉस J आ जाए, K क्रॉस K आ जाए, फिर वो साइन थीटा वाले चक्कर से बच जाएंगे, ठीक है। वी कैन इजिली फाइंड A क्रॉस B यूजिंग दिस, ठीक है। सो दिस इज आवर नेक्स्ट अप्रोच, ओके। यू कैन नोट इट डाउन बिकॉज वी आर रनिंग आउट ऑफ टाइम। डू वी हैव टाइम? सो यू कैन नोट डाउन दैट vector operations in terms of vector operations, next page पे लिख लो, next time we'll cover vector operations in terms of three rectangular components. Vector operations in terms of three rectangular components of vector, three rectangular components of vectors, ठीक है। We have got 2 minutes. If you want to ask any question, there is already a question. Can we divide vectors? I'm afraid we cannot, and the reason is that what I will do with the direction. How can people will forgive me for dividing north with south and resulting into east? I will be doing a crime because people might say that कि अच्छा वाह भाई बड़े जादूगर हो, नॉर्थ को साउथ से डिवाइड किया, ईस्ट निकाल लिया, किया कैसे? I will be in a trouble. So probably I'm sorry for such difficult situation. We say the people that division of the vector is not possible, not practical. Any other question? एक और था क्या? एक ही था? चलो एक इधर से आने वाला है, एक और क्वेश्चन आप पूछो, एक ऐसा क्वेश्चन पूछो जो हिला दो बिल्कुल। Axial. Any vector which is directing along any axis is axial. अभी हिला नहीं, थोड़ा और तेज और तगड़ा क्वेश्चन पूछो। Any question? Wonderful question. इसीलिए कहता हूँ पूछा करो. How do we know that we have to do dot and cross? And then should I ask you another question? How do you know that you have to add vector or subtract vector? So somebody might have said you add two vectors, तब तो add करोगे. Somebody might have said you subtract two vectors, तब तो subtract करोगे. But इतना simple होता तो क्या बात थी, फिर तो हर कोई जेई क्रैक कर लेता. The resultant. So one answer could be, if the resultant has to be a vector, then I'm sorry, you're not supposed to be doing the dot. So the knowledge of the resultant is required. Okay? And if the resultant is a scalar, then I'm sorry, you cannot do the cross product. ठीक है, एक मिनट के लिए ये भी आंसर बेकार है, सॉरी, यू नो व्हाई? बिकॉज कभी कभी जब सिचुएशन अटकेगी फंसेगी तो आप इवन एडिशन और सब्ट्रैक्शन में फंस जाओगे. मैं आपको एक सिंपल एग्जांपल दे रहा हूँ. मैं जस्ट 1 मिनट मोर सिंपल एग्जांपल दे रहा हूँ. ज़्यादातर 90% 11th क्लास के बच्चे अटक जाते हैं. when suppose a swimmer is crossing a river velocity is given and swimmer velocity is given. Will you go for the subtraction or addition of two vector? When I ask that in which direction swimmer will go, swimmer is making his effort in one direction. प्रैक्टिकल लाइफ में सबको पता क्या होगा. आई थिंक एवरीबडी नोज अगर स्विमर रिवर इधर है, स्विमर इधर प्रयास कर रहा, जाएगा कहीं और. विल यू डू द एडिशन ऑफ टू वेक्टर्स और द सब्ट्रैक्शन ऑफ टू वेक्टर्स? वन एग्जांपल, आंसर मत दो भी. सेकंड एग्जांपल, द केस विच द गर्ल वाज टॉकिंग द बिगिनिंग, आई थिंक विच गर्ल, रेन ड्रॉप. विल यू डू द एडिशन और सब्ट्रैक्शन? The two vehicles moving in the same direction, two vehicles moving in the same direction and opposite direction. One is observing other and vice versa. Case of relative velocity. Will you do subtraction or addition when they are moving in the same direction and where they move in opposite direction? From the knowledge of vectors अब तक पढ़ाया, if they are moving in opposite direction, you will do से ना सब्ट्रैक्शन. मैं चाहता हूं कुछ लोग बोले सब्ट्रैक्शन, क्योंकि अब तक मैं यही पढ़ा रहा हूं. व्हेन द टू वेक्टर्स आर इन अपोजिट डायरेक्शन, subtraction. When they same direction, addition. But the case of relative velocity is exactly opposite. So how do we know that when to add and when to subtract? Only answer to this question is as many number of problems as you can solve will definitely tell you when to add and when to subtract, when to dot and when to cross. जितने नंबर ऑफ क्वेश्चंस करोगे. मैं अक्सर बच्चों को बोलता हूं, इससे मैं खत्म कर रहा हूं एक लाइन से, कि हमसे ज्यादा इंटेलिजेंट आप हो. फिजिक्स मैं जानता हूं सिर्फ, आप क्या क्या जानते हो? केमिस्ट्री, ठीक है, मैथ्स, और भी पता नहीं बहुत कुछ जानते हो. आजकल तो आप लोग बहुत कुछ जान गए हो. गूगल बच्चे हैं सारे, गूगलिंग करते रहते हैं. हम कहते हैं हम बड़े इंटेलिजेंट. हाँ हम हैं, अभी भी कहते हैं, डंके की चोट पे कहते हैं. प्रॉब्लम क्या है हमारे इंटेलिजेंट होने? बताता हूं. हम इंटेलिजेंट इसलिए हैं क्योंकि अगर आपने 10 क्वेश्चन किया होगा, मैंने हो सकता है 1000 क्वेश्चन किया हो. डिफरेंस कितने का है? 990 क्वेश्चन का. आप किसी दिन 990 क्वेश्चन एक्स्ट्रा कर लेना, हम आप बराबर हो जाएंगे. तो हमारा आपका इंटेलिजेंस सिर्फ इसमें लाई करता है. हम सिर्फ आपसे एक माने में इंटेलिजेंट ज्यादा है. नंबर ऑफ क्वेश्चंस व्हिच आई हैव अटेम्प्टेड इज मोर एज कंपेयर टू यू. और माने में आप हमसे इंटेलिजेंट हो. ठीक है. तो अगर किसी भी टीचर के जैसा बनना है, या आपको ज्यादा क्वेश्चंस अगर आने हैं, या कंफ्यूजन हटाने दिमाग से, अटेम्प्ट एज मेनी नंबर ऑफ क्वेश्चंस एज पॉसिबल. देयर इज नो अदर वे. लेट मी टेल यू, देयर इज नो मैजिक. कोई कितना भी अच्छा पढ़ा दे, आप कितना भी मेहनत कर लो, अगर नंबर ऑफ क्वेश्चंस अटेम्प्ट नहीं करते हो, वो डोमेन नहीं बढ़ाते हो, तो आप वैसे ही रह जाओगे जैसे अभी हो. ठीक है. थैंक यू वेरी मच. इट हैज बीन प्लेजर अगेन टू टॉक टू यू.